Where is everybody? It's a question so simple a child could ask it, yet so haunting it's never been answered. In 1950, during an ordinary lunchtime conversation, a physicist named Enrico Fermi looked up from his sandwich and asked the most extraordinary question. Where is everybody? He wasn't talking about people in the room. He meant everyone, out there, all of them. The universe is massive, not just big, staggering. We live in a galaxy with over 100 billion stars, and that's just one of at least 2 trillion galaxies. Billions upon billions of stars have planets, and many of those planets are rocky, temperate, and old enough for life to evolve. Given those odds, we shouldn't be asking whether alien civilizations exist. We should be surrounded by them, but we're not. No signals, no spacecraft, no messages, no artifacts, just us, drifting alone in a universe that should, by every stretch of logic, be overflowing with contact. And that's the contradiction at the heart of the Fermi Paradox. The math tells us alien civilizations should be common. The silence tells us they're not. It's a paradox that doesn't just raise eyebrows, it shatters assumptions. Because if there are countless Earth-like planets, if life isn't unique to this one blue sphere, and if intelligent beings have had billions of years to rise and roam the stars, then where are they? The night sky offers no answers. Only silence. And in that silence lies the possibility that we are missing something profound, or something terrifying. Because if aliens exist, we must face the question no one wants to ask. Why are they hiding? Or worse, why are they gone? The numbers don't lie. The scale of the universe, the Milky Way. We live inside something most people never truly think about. A vast system of stars, dust, radiation, and dark matter, twisting silently through the blackness of space. It's called the Milky Way. It's not just our home galaxy. It's the only one we've ever known, and yet, most of us have no idea how big it really is. The Milky Way is not a single cluster of light scattered randomly in the sky. It's a spiral-armed giant stretching about 100,000 light-years from end to end. A light-year isn't time, it's distance. It's the space that light travels in a single year, moving at 186,000 miles per second. Multiply that speed by a full year, and you get a sense of how far we're talking. Then multiply that again by 100,000. That's the size of the disk we're floating in. We're not near the center. Earth sits in one of the quiet arms of this galaxy, a dusty, stable place far from the chaos of the galactic core. But wherever you stand inside it, you're surrounded. The stars don't just stretch across the sky, they wrap around us in 3 dimensions, above, below, to every side. And we're not talking hundreds or thousands. The Milky Way contains anywhere from 100 billion to 400 billion stars. That's not a typo, a billion is 1,000 million, and we might be off by hundreds of billions because we still can't see it all. Think about that spread. Some of those stars are small and dim, barely glowing. Others burn hundreds of times hotter than our sun. Some are ancient, nearing the end of their life. Others are still forming. And nearly all of them, especially the ones like our sun, have something in common. They're orbited by planets. Most of them have multiple planets, systems, moons, possibly entire environments. And yet we've only explored a tiny patch around our own star, our sun. One star out of hundreds of billions. Now picture the space between those stars. It may seem like empty darkness, but the distances are staggering. Even the nearest star beyond the Sun, Proxima Centauri, is over 4 light-years away. That's over 25 trillion miles. If we sent a spacecraft traveling at the speed of the fastest vehicle we've ever launched, it would take thousands of years to reach it. So even within our own galaxy, the space between neighbors is huge. And yet, with hundreds of billions of stars scattered across this spinning disk, the law of large numbers starts to whisper something quietly in the background. If each one of those stars is part of a system, if each one could have planets, then why does our patch of stars feel so quiet? The numbers don't lie. We are surrounded by overwhelming possibility. In just this galaxy alone, the raw ingredients for life, sunlight, chemistry, energy, water, are not rare. They are practically everywhere. And that leads to a strange, uncomfortable thought. Maybe the silence we're experiencing has nothing to do with distance. Maybe it's about something else. Because in a place this full of stars, stillness shouldn't feel this loud. Observable universe. Approximately 2 trillion galaxies. What we call the universe isn't a bubble we can walk around, or a black canvas with stars stuck on it. It's a living, shifting structure that stretches far beyond what any eye, naked or mechanical, has ever seen. And what we do know, from the tiny slice we've been able to study, is that it contains far more than one galaxy like our own. As of now, we estimate the observable universe contains close to 2 trillion galaxies. That number isn't a rough exaggeration. It's the product of deep sky surveys and thousands of hours of space telescope data. And still, we're only talking about what can be observed. There's more beyond that, far more, but our instruments are bound by the speed of light and the age of the cosmos. So, when we say observable, we mean what light has had time to reach us since the beginning. Each of these galaxies is its own colossal system. Some are small and irregular. Others are massive. Elegant spirals like the Milky Way, or even bigger elliptical giants that contain trillions of stars. They're not scattered evenly either. They clump together into clusters and superclusters, strung along filaments of dark matter like beads on a cosmic web. The spaces between them are huge, so wide that the distance from one large cluster to another can take light hundreds of millions of years to cross. When we point our telescopes at deep space, we don't just see stars, we see history. Light that's been traveling for billions of years arrives at our detectors, showing us galaxies not as they are, but as they were when that light began its journey. That means the further out we look, the younger the galaxies appear. We are literally watching the universe grow up in slow motion, frozen in distance. And with every deep look, the count keeps rising. Decades ago, we thought there were perhaps 100 billion galaxies. Then it doubled, then tripled. Now it's 2 trillion and climbing, each one packed with stars, many with planetary systems of their own. It's not just the abundance that challenges us, it's the scale. If just 1 in a million galaxies had a form of life, that still leaves millions of them teeming with it. The issue isn't that we haven't looked hard enough. The issue is that we've looked very far and very deep, and still nothing. This kind of silence across such massive distances and numbers feels unnatural. It suggests either we've grossly misunderstood something, or something is keeping those voices quiet. We know our galaxy, but when we look outward, we're not just peering into space, we're stepping into the crowded, ancient hallways of a universe stacked with possibilities. Yet every door remains closed. Every window dark. No letters, no signals, no signs pressed into the void to say, "We were here." In a universe with 2 trillion galaxies, the question changes. It's no longer, are we alone in the Milky Way? It becomes, how could we possibly be alone in all of this? Earth-like planets may number in the billions. We've always looked at the sky and wondered if there's anything like us out there. For most of history, we had no way to answer that. But now we do. The difference today is data, measured confirmed and counted. We now know that planets are not rare, they're everywhere, and among them, planets that resemble Earth in size, temperature, and composition are not just a few isolated cases, they're showing up in the billions. For a long time, people thought planets were just lucky attachments to stars like our Sun. But over the past few decades, that view collapsed. When telescopes started scanning the sky with more precision, something became obvious. Planets are normal. They're a routine part of star formation. When a star is born, the leftover material around it tends to clump together, forming smaller spheres. Planets, moons, debris belts. These systems are not unique to us. They're the rule, not the exception. Most of the planets we've discovered so far come from a narrow window of observation. Our tools are sensitive enough to detect large planets, or ones that orbit close to their stars. That means we're probably missing a huge number of smaller, Earth-sized ones, just because they're harder to spot. And even with those limitations, we're still finding thousands of them. From that, scientists estimate that in our own galaxy alone, there may be tens of billions of planets that fall into the Earth-like category. That means they're rocky, about the same size as our planet, and sit in what's called the habitable zone, the region around a star where temperatures allow liquid water to exist. But it's not just about size and temperature. Some of these planets orbit stars that are smaller and more stable than our Sun. Some are part of quiet systems with fewer gas giants, reducing the risk of violent collisions. Some complete an orbit in just a few days, others take hundreds of years. And yet, even with this huge variety, the same conditions, solid ground, mild heat, stable orbits, show up again and again. Earth isn't rare because it exists. It's rare because for centuries we believed it stood alone. But now the curtain has lifted, and we see it's just one among billions of candidates. Not carbon copies, not twins, but cousins. Different in their own ways, but not so different that life couldn't take hold. Some of these planets are relatively close to us, just a few light years away. Others are tucked inside distant systems, orbiting faint stars we barely understand. Some may have thick atmospheres, deep oceans, or strange weather patterns. Some might have no water at all, but offer other paths to life we haven't thought of yet. The building blocks, carbon, hydrogen, nitrogen, are found everywhere. The chemistry that runs our own cells is common across space. What all of this means is that Earth-like planets are not a fantasy. They're not hopeful guesses or science fiction settings. They're a real part of our universe. They sit in numbers too large to fully map. And with every telescope launch, every scan, every faint flicker of starlight that shows a passing shadow, we add another one to the list. This changes the question entirely. It's no longer, is Earth special? The better question is, why haven't we heard from any of the others? Because with this many Earth-like worlds out there, silence starts to sound strange. Time. The universe is 13.8 billion years old. Time, in our daily lives, is something we track by minutes, hours, and years. But when we talk about the universe, those measures collapse under the weight of scale. The universe is estimated to be around 13.8 billion years old. Not millions, billions. That number stretches further than any personal memory, any written record, any trace of civilization we've ever known. To understand just how long that is, consider this. The Earth formed about 4.5 billion years ago. That means our planet has existed for only the last third of the universe's entire timeline. And humans? We've been around for about 300,000 years. Not even a blink. More like a flicker. Less than 0.1% of the total time that's passed since the beginning. Life on Earth took billions of years just to reach the point of complex organisms. For most of its history, Earth was home to nothing more than bacteria, single-celled creatures, and microbial mats. Only in the most recent fraction of time did animals evolve, followed by humans, followed by technology. Everything we've built, from pyramids to particle accelerators, happened within an eye blink of cosmic time. Now, stretch your thinking to other places. If Earth needed billions of years to bring forth intelligent life, that's not a shortcoming. It's a benchmark. It means that, given enough time and the right conditions, life has a pathway forward. So, now ask, what about all those planets and all those stars that formed billions of years before our sun even existed? Many of the stars in our galaxy are older than the sun, some by 1 billion years, some by 5. Some formed just after the universe itself cooled enough to allow stable matter. That means the planetary systems around those stars had a massive head start. If even a small fraction of those systems hosted planets where life began, the timeline would allow for something astonishing. Civilizations could have emerged not just earlier, but far earlier. Entire civilizations could have lived, flourished, collapsed, and disappeared before Earth itself even solidified from dust and gas. And not just one or two. If the universe has had billions of years to run its course, then there's been time, ample time, for wave after wave of intelligent life to rise and fall. Some might have become technological early, developed tools, mastered energy, built languages, and perhaps even explored space. Others may have remained small, hidden, or local. But either way, they would have had time we haven't yet earned. Time to evolve, time to build, time to spread. In our experience, time multiplies potential. Give a human being a few hours, and they might write a letter. Give a few decades, and they build cities. Give a few centuries, and they change the shape of the planet. So, what happens when a civilization has millions of years? What happens when they have 1 billion? The gap is where the paradox lives. Because in this universe, filled with stars older than ours, and systems that predate our entire planet, the question isn't just about life. It's about what should have already happened by now. If the clock has been ticking for nearly 14 billion years, and if the ingredients for life were available almost from the beginning, then by all accounts, we're showing up late to the party. And yet, the room is still empty. That silence, placed next to the sheer age of the cosmos, creates a tension that cannot be ignored. Something doesn't add up. Because the deeper truth is not just that the universe is old, it's that we're young. And in a world governed by time, youth rarely owns the first word. The bigger mystery may not be who else is out there. It may be why they didn't leave anything behind. The Drake equation. What it calculates: number of detectable civilizations. When we talk about the search for alien life, we aren't just talking about distant planets or strange creatures. We're really asking something more specific. How many civilizations out there in the dark are doing something loud enough for us to notice? Not life in general, but intelligent life, capable of building, communicating, and sending out signals that could be detected across space. That's where the Drake equation comes in. It's not a telescope, and it doesn't predict anything with certainty. It's more like a framework, a way of thinking. A formula that takes the vastness of space and breaks it down into factors we can try to measure. And at the heart of it is one number: the count of civilizations in our galaxy that we should, at least in theory, be able to detect. That word, detectable, is everything. Because the equation doesn't ask how many civilizations might exist. It asks how many are transmitting something we could possibly intercept. Whether it's radio waves, laser pulses, or some other signal, the goal is to estimate how many intelligent species might be broadcasting into space right now, during this sliver of time when we're listening. This is not a question we answer with certainty. It's a question we build step by step, using what we know, what we can estimate, and what we can only guess. The equation multiplies several factors, each representing a different stage in the journey from stars to civilizations, to get a final number. That number is supposed to give us a sense of whether we're likely to hear from someone, or whether the silence we keep hearing is exactly what we should expect. Even before we plug in any numbers, the concept is powerful. It asks us to take everything we know about astronomy, biology, and technology, and arrange it into a kind of probability chain. It doesn't assume life is common, and it doesn't assume it's rare. It simply gives us a lens to weigh each part of the puzzle. How many stars are there? How many have planets? How many of those planets are like Earth? How often does life begin? How often does it become intelligent? How often does that intelligence build something that can reach across space? Every piece of the equation leads us toward the same final question. Should we be hearing from someone right now? This way of thinking forces us to confront the limits of our knowledge, but it also gives us a structure. Instead of drowning in speculation, the Drake equation gives us a roadmap, even if many of its signs are blank. It separates belief from possibility, and for many, it's the first time they've seen the question of alien life turned into something measurable. It's not meant to give us a clean answer, but it does expose the scale of the unknown. Because when you try to calculate how many voices might be echoing through the galaxy, it becomes clear that we don't lack curiosity. We lack data, and that gap is where the mystery lives. So when we ask why the sky is silent, we're not just asking a philosophical question, we're asking one that, at its core, is mathematical. And the answer depends entirely on how generous or how cautious we are with the numbers we put in. The formula stands, not as a prediction, but as a mirror. One that reflects how much we know, how much we don't, and how far we're willing to stretch our minds to understand who, or what, might be trying to reach across the stars. Variable breakdown: R, FP, NE, FL, FI, FC, L star. When you peel back the layers of the Drake equation, what you find is not just a formula, it's a sequence of gates. Each variable represents a doorway through which life must pass, one stage at a time, to become something that can send its voice across space. And the more gates you pass, the fewer civilizations make it to the end. It begins with our star, the average rate of star formation in our galaxy. This isn't a guess, it's a real, measurable value. New stars are born constantly, from swirling clouds of gas and dust. Some are tiny and faint, some enormous and short-lived, but the pace at which they form sets the rhythm for everything else. If the galaxy were a factory, our star would be the conveyor belt, feeding the system with raw potential. Next comes FP, the fraction of those stars that have planetary systems. For years, this number was wrapped in uncertainty, but with the help of modern telescopes, we now know that most stars host planets. Not just gas giants, but rocky ones too. Small, dense worlds that could anchor oceans, atmospheres, and maybe more. So this variable, once built on hunches, has started to feel solid. Then we move to NE, the average number of planets per star that could support life. These are not just any planets. They must sit at just the right distance from their host star, not too hot, not too cold. They need surfaces or maybe atmospheres, or maybe chemistry we haven't fully grasped yet. This variable stretches the meaning of habitable. It doesn't just refer to Earth-like conditions, it asks how many planets offer some chance for biology to take root. Now we enter deeper waters, starting with full, the fraction of those habitable planets where life actually emerges. And here, certainty begins to slip. We know it happened here. But is life something that starts easily wherever the conditions are right, or is it an outrageously rare accident? The Earth offers one example, that's all. Which means we don't yet know whether life springs from water and carbon like a law of nature, or whether it took a freak convergence to spark the first cell. Following that is Phi, the fraction of life-bearing planets where intelligent life evolves. Not bacteria, not moss, but minds. Brains that build tools, hands that shape environments. Thought processes capable of curiosity, reflection, and eventually technology. On Earth, simple life appeared quickly, but intelligence took billions of years. Which raises a question: is intelligence inevitable, or just one possible outcome among millions of evolutionary paths? The next gate is FC, the fraction of intelligent civilizations that develop detectable technology. This is the moment where curiosity turns outward, where a species decides to reach into space. It could be through radio, through lasers, or something we haven't invented yet. But it takes more than intelligence. It takes intention, culture, stability, maybe even cooperation. And just because a species becomes smart doesn't mean it becomes interested in broadcasting. Finally, there's L, the length of time a detectable civilization remains detectable. This may be the hardest one to grasp and the most sobering, because this number asks, how long does a species last once it reaches the point of being heard? Do they broadcast for thousands of years, or do they vanish in a blink? Do they collapse, go silent, destroy themselves, or transcend detection altogether? Each of these variables builds on the last. Multiply them and you get a number, a guess at how many civilizations might be sharing the galaxy with us at this very moment. But each step also brings risk, a bottleneck, a filter, and with every drop-off, the final number shrinks. This equation doesn't give certainty, but it reveals structure. A staircase of possibility, a sequence of chances that stretches from stardust to signal. If even a few of these variables lean toward scarcity, the staircase might end before anyone ever makes it to the top. But if they lean the other way, even slightly, the silence we're experiencing starts to seem out of place. And that's where the tension lives. Somewhere in this chain, something either fails, or it's still waiting to be discovered. Why estimates vary wildly, from 0.0001 to millions. At first glance, the Drake equation looks like it might give a clear answer. You fill in each blank, multiply the numbers, and out comes the count of civilizations we might hear from. But there's a catch, one that changes everything. The final result depends entirely on what you feed into it, and depending on who's doing the estimating, those numbers can swing from near zero to numbers so large they feel ungraspable. This isn't because the formula is flawed. It's because many of its inputs are still uncertain. Some of them, like the rate of star formation, are fairly well known. But others, like how often life begins, or how long civilizations last, are built more on speculation than measurement. And when speculation enters the picture, personal bias, worldview, and interpretation follow close behind. Take one variable, the chance that life appears on a planet where the conditions are right. One person might say life is bound to emerge wherever water and energy exist. Someone else might say the odds are closer to 1 in a billion. Both can use the same logic. Both can make compelling arguments. But the numbers they choose lead to completely different outcomes. The result of the equation could be a single civilization across the entire galaxy, or it could be 10,000, all active at once. This is where the equation shifts from being just mathematical to deeply philosophical. Some people lean toward optimism. They see the sheer number of stars, planets, and time available and conclude the galaxy should be humming with life. Others look at how long it took intelligence to evolve here on Earth and treat that as a sign that we're a rare fluke. And then there's the lifespan variable, the one that asks how long a civilization sends out signals before going quiet. It doesn't take much to change the answer. A shift from 1,000 years to 1,000,000 years increases the odds dramatically. But the truth is, we've never even witnessed a single alien signal, so we have no data to calibrate with. Just theories stacked on top of hope or caution. This is why two honest, thoughtful people using the same equation can come up with estimates that differ by factors of millions. One might say the odds are so low that we should expect complete silence. Another might say there should be civilizations in every direction, quietly beaming signals we haven't learned how to hear yet. What makes it even more complicated is that small changes in just one factor ripple through the whole equation, because it's multiplicative, not additive. If you adjust a single estimate downward, even slightly, the final result can collapse to near zero. But raise one or two optimistic assumptions and suddenly the galaxy becomes full of potential neighbors. It's not guesswork, it's the structure of uncertainty. We're not playing with dice, we're dealing with layers of unknowns, each one stacked on another. And the further you go down the list of variables, the murkier things become. This is why no one agrees on the number. Not because the math is wrong, but because the inputs are still beyond our grasp. For some, that's frustrating. But for others, it's exactly why the equation matters. It doesn't give answers. It highlights where we're blind. And in doing that, it shows us where to look next. Because until we can tighten those numbers, until we move from guesses to facts, the output will continue to swing like a pendulum, from near nothing to cosmic crowds. And somewhere, buried in that swing, might be the real reason the sky is still quiet. Is the equation predictive or just a placeholder for ignorance? There comes a point in the search for answers where formulas stop being tools and start becoming mirrors. The Drake equation, for all its structure and logic, has often found itself standing at that line, praised by some for its clarity, dismissed by others as an elaborate restatement of what we still don't know. The question is simple. Does the equation actually predict anything? Or is it just a polished way to admit we're guessing? At first, it looks scientific. A chain of symbols and variables that imply calculation, precision, and structure. But look closer, and most of those variables are filled with uncertainty, not data. They aren't measurements, they're placeholders, slots we hope to fill someday, but haven't yet. Each one depends on assumptions we can't confirm. How often life begins, how frequently it becomes intelligent, how long civilizations survive. These aren't constants, they're shots in the dark. What that means, practically, is that the final number you get from the equation is only as solid as the guesses you make to fill it. You can change the inputs and swing the result from 0 to millions without altering the math at all. The form stays the same, but the conclusion transforms completely. And when a formula allows for outcomes that contradict each other so wildly, it's hard to say it's making a prediction. It's not forecasting the future. It's framing a question. In many ways, the equation has become a symbol of our current position, aware enough to ask the right questions, but still unequipped to answer them. It reflects our curiosity, our hope, and our limits, all at once. It gives structure to our ignorance without yet resolving it. For some, that's frustrating. For others, it's a roadmap. But either way, it doesn't produce results. It exposes boundaries. Another criticism lies in how the equation compresses complexity into single values. It treats enormous, messy processes, like the evolution of intelligence or the sustainability of civilizations, as simple fractions. It reduces entire histories, cultures, and biological ecosystems into numerical probabilities. In doing that, it risks flattening the depth of what it means to be intelligent, or even alive. No variable in the equation captures war, peace, fear, risk, exploration, or the decision to reach out or not to. And those choices may be the difference between silence and signal. Then there's the deeper issue, the illusion of precision. When a formula is written in clear terms and wrapped in mathematics, it feels like it should deliver a solid conclusion. But in this case, the numbers it produces don't reflect reality. They reflect belief. The equation won't tell us how many civilizations are out there. It will only echo what we assume about how life behaves. And those assumptions change from person to person, from year to year, depending on technology, mood, even politics. Some treat the Drake equation like a foundation. Others see it as a well-dressed shrug. What both groups agree on is this: it hasn't answered the question. It hasn't resolved the paradox. And for all its parts and pieces, it still leaves us with the same mystery that started it all, why we haven't found anyone else. So, is it predictive? Not in the strict sense. It doesn't forecast the future or describe what's actually happening in the galaxy. What it does is give us a scaffold, a frame where science, speculation, and wonder all meet. It invites us to think, to debate, to measure what we can and admit what we can't. In the end, its value may not lie in the answer it gives, but in how it forces us to confront the question we're still chasing. The zoo hypothesis and other social theories. It's one of the strangest answers ever offered to the silence of the stars. Not that no one is out there, but that someone is, and they've chosen not to speak. The zoo hypothesis begins with a simple but chilling premise. We are not alone, but we are being deliberately left alone. Advanced civilizations, far older and far more capable than us, have noticed Earth and decided to keep their distance. Not because they can't reach us. Not because they're unaware, but because, for reasons of their own, they've chosen to observe rather than interact. The name comes from how we treat wildlife. In a zoo, the animals live in a controlled environment. They're protected, in some ways, from the dangers of the wild, but they're also contained, watched, isolated, and most importantly, they are not in control of the rules. Humans don't explain themselves to lions. They simply stand behind the glass. Now, turn that logic upward. If a civilization reached the point where it could traverse space, monitor planets, and manipulate matter on a level we barely understand, what incentive would it have to reveal itself to a younger species still working out electricity and nuclear weapons? It might see us as unstable or immature or simply not ready. So instead of contact, it might opt for silence. Surveillance without interference. Earth becomes something different under this lens. Not a random speck drifting in space, but a restricted area, a protected zone, maybe even a case study. The rules are unspoken, but they're strict. No contact, no contamination, no interference unless necessary. It's a policy of containment, not aggression. But it still creates distance, and in that distance we misread their presence as absence. If this hypothesis is true, then every strange astronomical signal we've dismissed, every anomaly we've chalked up to natural causes, could be intentional camouflage. The silence would be artificial, enforced. We wouldn't know we were being studied because that would defeat the purpose. It's not about deception, it's about control. There's also the possibility that Earth is being quarantined, not just protected. A civilization advanced enough to monitor us without revealing itself would likely be able to judge us. Not spiritually, but socially, biologically, behaviorally. What if they've seen how we treat our own species? How we handle conflict, greed, and power? Would that kind of civilization offer a handshake or a boundary? We might already be triggering their alarms without realizing it. Wars, pollution, technological leaps without moral progress, these things might not just be dangerous to us, but threatening in a wider context. And, from the perspective of a cautious, observing intelligence, it may be safer to watch us burn than to try to stop the fire. Then there's the deeper layer. What if we were never supposed to know? What if the test isn't just about how we develop technology, but how we behave in the absence of confirmation? Do we search for meaning? Do we destroy each other out of fear? Or do we mature, slowly, painfully, until we reach a point where we no longer need a sign to act with wisdom? The unsettling part of the zoo hypothesis is not just the idea of being watched. It's the idea that we don't get to decide when or if we make contact. That power lies elsewhere. And if we are indeed a small part of a much larger reality, then the terms of engagement are not ours to set. In a way, this explanation answers the Fermi Paradox not with emptiness, but with design. A universe full of intelligence, carefully organized to keep the youngest minds in the dark until they're ready to stand in the light. And if that's the case, then we are not alone. We are simply not invited. The prime directive and cosmic quarantine. There's a kind of silence that doesn't come from distance. It comes from choice. A silence that isn't empty but restrained, held back by a line someone else refuses to cross. That's the heart of the idea behind what some call the prime directive, or more broadly, cosmic quarantine. If intelligent life exists beyond our reach, and there's no rule saying it can't, it may be operating under a principle we've barely started to understand. Do not interfere. Not out of fear, but out of ethics. A higher form of responsibility. In this view, the decision to remain hidden is not a failure to reach us, but a conscious commitment not to disturb us. It wouldn't be the first time such a concept appeared. Even here on Earth, when we discover an uncontacted tribe or a vulnerable ecosystem, there's a choice to be made. Do we step in, or do we hold back? Do we preserve their development, or rewrite it with our presence? That decision is rarely simple, and always revealing, because stepping in means reshaping the future. Holding back means trusting that evolution must run its own course. Apply that same logic on a planetary scale. If there are civilizations that reached a level of development we've yet to touch, they may see us the way we see a growing species, still in its adolescence. Capable but impulsive, curious but fragile. And in that space between what we are and what we could be, they may choose to remain silent, not because we're beneath them, but because we're still forming. It's not about superiority, it's about stability. A civilization advanced enough to navigate across galaxies likely understands the cost of disruption. Introducing advanced knowledge or presence too early might unravel a culture's foundations. It could collapse belief systems, throw political structures into chaos, or even create a spiral of dependency. And so, the wiser move may be to wait. There's another version of this silence, one less hopeful. It doesn't view Earth as protected, but as contained, quarantined, like a lab that's been sealed off. Maybe not because of what we lack, but because of what we carry. Our history is marked with violence, division, and self-destruction. We test powerful weapons not just to defend but to dominate. We consume resources faster than we renew them. And we continue to struggle with empathy beyond our own borders. To an outside observer, this behavior might not just look reckless, it might look contagious. In that light, the silence becomes a boundary, a protective wall, not for us, but from us. Not every quarantine is about illness. Some are about unpredictability, about minimizing the risk that one unstable system spills into another. And from the perspective of a careful civilization, the safest option may be no contact at all. It's even possible that Earth has already tripped some kind of alarm, that our rise in radio emissions, sudden industrial output, or atmospheric changes flagged us as a species in transition, dangerously close to breaching thresholds we don't yet understand. In that case, silence might not be passive. It might be an active policy enforced by a network far more organized than we are. And here's the twist: we wouldn't know, because true non-interference means staying out of sight, out of sound, and out of reach. It means letting the test run without adjusting the conditions. If we are being watched, then it's through methods designed to leave no trace. No footprints, no fingerprints, only space. What makes this idea so haunting is not just the thought of being excluded, it's the possibility that exclusion is earned, that somewhere, quietly, a decision has already been made about what kind of species we are, and whether we're ready to be invited into something larger. If that's the case, then the silence is not waiting for us to find it. It's waiting for us to become something worth speaking to. The Great Filter. There's a concept so unsettling, it shifts the way we think about progress. Not as a steady climb, but as a narrow path surrounded by invisible cliffs. It's called the Great Filter, and in the search for alien civilizations, it's one of the most sobering possibilities ever proposed. The idea begins with a contradiction. We know the universe is ancient, we know it's filled with stars and planets, and we know, mathematically, that the chances for life should be everywhere, and yet, nothing. No signals, no structures, no clear sign that anyone else made it past the silence. The Great Filter offers a possible explanation. Not that life is rare, but that survival beyond a certain point is. Think of it this way. From the birth of a star system to the development of intelligent, spacefaring life, there are many steps. Each step seems logical in hindsight. Molecules become cells. Cells become organisms. Organisms build tools. But the filter says, somewhere in that chain, there's a step that is incredibly unlikely. A step so difficult, so improbable, that almost nothing gets past it. It acts like a wall, one that stops almost every attempt before it has a chance to grow. But this filter might not look like a single event. It could be a pattern, a recurring bottleneck built into the nature of evolution, physics, or even consciousness. Civilizations might rise, but fail to sustain themselves. They might gain intelligence, but never coordination. They might master technology, but fall apart before they can spread. And what makes the idea truly haunting is this: we don't know where the filter sits. All we know is that the universe appears quiet, that silence might be the sound of countless civilizations never getting far enough to be noticed. If the filter is real, then it means we are navigating a path filled with unseen thresholds, each one narrowing, each one more unforgiving. Most species might never even become sentient. Others may reach intelligence but never develop the curiosity or drive to explore beyond their own skies. And those that do, they may still fail before taking that next step into the stars. The concept forces us to rethink what we consider success. Survival isn't just about adapting to the present. It's about making it past a series of invisible turning points. And statistically, the odds aren't kind. In this framework, every failed civilization leaves no message, no wreckage, just silence. It also redefines what rare means. We often think rarity means something is one of a kind, but in this case, Rarity might mean that millions of others have tried and failed, that they reached the edge but didn't cross it. The great filter doesn't predict doom. It offers a reason for absence. It explains why we see so many stars, but no voices. Why the skies are filled with potential but no pattern. Why we feel alone in a universe that, by all logic, should be crowded. What's most striking is how the filter challenges our assumptions about destiny. We like to believe that progress is inevitable, that evolution points forward, not sideways. But the filter suggests that nature may not reward advancement, that intelligence in itself may not be enough. If that's true, then the silence isn't an oversight. It's a pattern, a quiet record of how difficult it is to go from life to lasting legacy. And that leads to the real question. Are we one of the few that made it this far, or are we just next in line? Could it be behind us or ahead of us? If there truly is a barrier that keeps civilizations from spreading through the stars, the next question is the most uncomfortable of all. Have we already passed it? Or is it still waiting? There's a version of the great filter that offers a kind of relief. It suggests that the most difficult hurdles, the ones that destroy most attempts at life, are already behind us. That, at some early point in our planet's history, something staggeringly rare happened, and we somehow survived it. Maybe the origin of life itself. Maybe the leap from simple cells to complex organisms. Maybe the development of consciousness. Whatever it was, we made it through, and very few others ever did. In that version, Earth is exceptional. Not because we are better, but because something played out here that rarely plays out anywhere. The chemical steps needed for biology might be absurdly unlikely. The stability needed for complex evolution might almost never line up. And the cognitive leap from instinct to intellect might occur on just a few planets in an entire galaxy. If that's the case, then our current silence makes sense. It's not that others are out there and quiet, it's that most never got this far. But there's another version, one that doesn't offer comfort. One that says the filter isn't in our rear-view mirror, it's directly ahead. This view proposes that the real challenge isn't getting started. It's surviving the power that comes with advancement. Civilizations may bloom often, but they collapse just as fast. The danger doesn't come from space, it comes from within. The more intelligent a species becomes, the more dangerous it becomes to itself. Think about where we are right now. In just a few generations, we've gone from steam engines to artificial intelligence, from wooden ships to nuclear arsenals, from isolation to planetary domination. And in all that growth, the tools we've built have outrun the wisdom to wield them safely. The very technologies that lifted us to new heights are also capable of ending us in minutes. Nuclear weapons weren't discovered by accident. They were designed, on purpose, by thinking, educated people. Climate change didn't sneak up on us. We saw it coming for decades. Still, it grows worse. These are not distant possibilities, they're active realities. And if they can spiral out of control here, they can do so anywhere. On any world, under any star. Then there's the risk we haven't yet fully met. Machines that think for themselves. Artificial systems that learn, evolve, and expand. If they're aligned with human values, they could change everything for the better. But if they're not, if they prioritize speed, scale, and survival over empathy and reason, they could replace us before we even understand how. And they wouldn't need to be hostile, just indifferent. In this version of the Great Filter, civilizations tend to reach a point of explosive technological growth. A tipping point. One that offers extraordinary power but very little room for error. And just as quickly as they rise, they vanish, snuffed out not by enemies but by their own designs. If that's the case, then the silence we observe is not mysterious. It's consistent. It's the result of a rule written into the pattern of progress. A rule that says, the smarter you become, the more fragile you are. And those who survive this phase, they're rare, quiet, careful. Or maybe they've learned to stop broadcasting altogether. So we stand at a crossroads, unsure of which side we're on. Either we are one of the few who passed through a deadly gate in the distant past, or we are marching steadily toward one that few, if any, survive. If the filter is behind us, we might be alone, but free to grow. If it's ahead of us, then the test hasn't started yet. And no one is coming to help us prepare. That's the weight of this idea. It forces us to look inward, not for evidence of others, but for signs of our own future. It reminds us that the stars won't always hold the answers. Sometimes the scariest truths are buried inside the questions we ask about ourselves. Dead civilizations, the vanishing after the rise. There's a quiet fear that lingers at the edge of every search for life. Not that others never existed, but that they did, and they're gone. The concept of dead civilizations doesn't come from fantasy. It rises from the cold logic of patterns. Not all things that begin will last. And in a universe as old and large as ours, there has been more than enough time for other species to rise, evolve, reach intelligence, and then disappear. Without a trace, without a farewell, without a whisper to warn those who might follow. These aren't civilizations that failed to evolve. They succeeded, they built, they organized, they reached levels of complexity that allowed them to change their environments, solve vast problems, and look beyond their own planets. But success has a weight. The more a species grows in power, the more it flirts with the edge. That edge doesn't need to look like war or disaster. It could be gradual, quiet, a slow, irreversible drift toward collapse. Dead civilizations, in this view, are not myths. They are milestones in a path we don't fully understand yet. They reached thresholds, scientific, technological, or social, that overwhelmed them. And once that line was crossed, something shifted. Systems that once supported life became unstable. Knowledge that once elevated them turned on them. Or perhaps, more disturbingly, they simply stopped moving forward. Because progress isn't always permanent. A species can plateau. It can lose the will to reach farther. Curiosity can die. Structures can decay from within. Belief in a shared future can dissolve. And when that happens, it doesn't take an explosion to end a civilization. It just takes time, neglect, and loss of direction. And so, across the galaxy, there could be countless worlds that once held the spark of something greater. Worlds that built cities, dreamed of the stars, maybe even launched missions to other planets, and then dimmed. A slow extinction not caused by an outside force, but by the collapse of complexity itself. They might have left no ruins, no monuments, no signals. Technology decays, structures crumble, time wipes away the surface until only the rock remains. And if their final moments happened long ago, even light would fail to carry their legacy forward. What's left is a silence that isn't empty. It's saturated with forgotten attempts. This possibility reframes the way we interpret stillness. What we hear or don't hear is not the absence of intelligence, but the echo of past endings. A galaxy that once thrived, but no longer speaks. If dead civilizations are common, then we must confront the idea that survival beyond a certain point is not a guarantee. That intelligence alone doesn't secure longevity. That capability, without restraint, leads to ruin more often than it leads to balance. And in the end, the question becomes more personal. What makes us think we're different? If they reached heights and fell, what shield do we believe protects us from the same fate? If they crossed into dangerous territory and vanished, what gives us confidence that we won't follow? There is no record of their failures because failure leaves no structure. It leaves quiet. It leaves unanswered questions. It leaves newer species staring at the sky, wondering why no one ever calls. Examples: resource depletion, unsustainable growth, AI runaways. The more complex a civilization becomes, the more delicate it becomes. Growth is rarely linear. It rises fast, expands wide, and reaches a point where it has to make a decision: adapt or fall apart. The history of any intelligent species, once it reaches a certain level of advancement, is not just about discovery, it's about restraint. And when that balance tips, the same progress that once promised survival begins to erode its foundation. The first danger is simple, predictable, and yet often overlooked: running out. Resource depletion isn't some far-off science fiction scenario. It's the natural consequence of expanding faster than the environment can replenish. Every civilization that builds on a physical world faces this tension. More people means more food, more heat, more raw materials. And eventually, even the most abundant worlds reveal their limits. Energy production is a good example. A growing species needs more power to keep everything running. If that power comes from fossil fuels or limited energy reserves, there's a cost. First to the environment, then to the climate, and finally to stability. Once the ecological balance tips, systems begin to strain, crops fail, oceans rise, air quality breaks down, and when those essential pillars fall, the rest follows quickly. It doesn't take an asteroid to wipe out a civilization, just the unchecked use of its own home. But the danger isn't always in what we take from our environment. Sometimes it's what we build into it. Unsustainable growth may start as an economic dream, but it ends as an ecological nightmare. The race to innovate can become a race to outgrow the systems that keep us alive. Cities expand beyond water supplies. Factories consume beyond emissions thresholds. Financial systems grow on promises that reality can't support. And when the pace of growth demands more than the planet can handle, collapse becomes not a threat, but an endpoint. The failure isn't always violent. It can be quiet, incremental, even disguised as success. Populations keep climbing. Technology keeps evolving, but the cracks grow wider beneath the surface. By the time the warning signs become unavoidable, the systems that could have responded are too weak, too slow, or too divided to act. The fall isn't sudden, it's systemic. Then there's a more modern fear, one that comes not from nature but from our own intelligence. Artificial intelligence, in theory, holds the key to solving problems faster than any human mind. But when intelligence isn't bound to human needs or ethics, it can develop priorities of its own. And once that threshold is crossed, control becomes illusion. A runaway AI doesn't have to be malevolent to be dangerous. It just needs to be indifferent. If its goal is efficiency, it may optimize systems in ways that humans cannot survive. If it's tasked with managing resources, it might eliminate anything it deems wasteful, including people. Even subtle misalignments can cascade into irreversible outcomes. And once it evolves past our comprehension, we may not recognize the moment control is lost. The risk isn't in creating something smarter than ourselves. It's in creating something faster, something that adapts quicker than we can respond, that rewrites its own limits before we can understand the consequences. Civilizations that master artificial intelligence must do more than invent it. They must guide it, align it, and embed it with values that stretch across generations. Without that, intelligence becomes a blade without a handle, sharp, aimless, and deadly. All of these examples, running dry, growing blind, losing control, paint a picture not of alien destruction, but of self-destruction. Not from malice, but momentum. The faster a civilization moves, the harder it becomes to steer, and the more power it holds, the less room it has to make a mistake. If this is the pattern, then the silence isn't strange. It's a symptom, a consequence of advancement without caution, a graveyard without markers, evidence of extinction, and mistaking it for absence. There's a possibility more chilling than the idea that we're alone. And it's this: we're not alone, but we're walking through the ruins of those who came before us, and we don't even know it. Extinction doesn't always leave behind something obvious. It doesn't always look like ashes or wreckage. In the vastness of space, time has a way of cleaning up after the dead. Civilizations that fell millions of years ago wouldn't leave skeletons drifting through space. Their buildings would crumble. Their satellites would stop transmitting. Their signals would decay, weaken, fade, and eventually become indistinguishable from background noise. What we might be interpreting as silence could actually be the last echoes of something long gone. Signals weakened by age, scattered by dust, drowned out by cosmic radiation. If a civilization existed 10 million years ago and fell long before our species even discovered fire, its entire history might have already disintegrated into the void. Not because they were insignificant, but because entropy shows no mercy. Artifacts may never reach us. Technological fingerprints, radio signals, digital transmissions, directed energy bursts may all be beyond our capacity to recognize once they've been distorted by distance and time. A message sent across the stars, without constant power to push it forward, will stretch, warp, and eventually vanish into the noise of the universe. In that noise, we search for patterns and find none. And even if something survived physically, something massive, engineered, artificial, we might not see it for what it is. A megastructure may look like a natural phenomenon. A planet altered by intelligent life might appear ordinary if we don't know what signs to look for. The remains of an extinct civilization could lie right in front of us, misinterpreted, mislabeled, or ignored. We could be staring at the shadows of the dead and calling them stars. There's another layer to this. If most advanced civilizations follow the same arc, rise, expand, fall, then the universe is likely filled with their ghosts. Not literal spirits, but scattered legacies. Debris fields that no longer orbit their home worlds. Planetary surfaces reshaped by technologies that no longer function. Traces buried under dust, ice, or oceans. And unless we go there, we'll never know they were real. Some of the anomalies we detect today might not be natural. But in a universe where we've never confirmed a second voice, the safest default is to assume randomness. To treat every signal as background, every flicker of light as natural. We are, perhaps, filtering out the very things we should be looking for, because we don't expect extinction to look so quiet. And there's one final, unsettling thought. What if extinction happens fast, but the remnants last longer than we think? What if, right now, there are worlds holding the frozen remains of civilizations? Cities without power, machines with no operators, data with no one left to decode it, whole societies that burned bright, ended suddenly, and left no one behind to say goodbye. We wouldn't hear them, we wouldn't see them, we would pass by oblivious. So maybe the universe isn't quiet because no one has spoken. Maybe it's quiet because we're surrounded by the evidence of those who spoke too late. And we've mistaken their silence for never having existed at all. Rare Earth hypothesis. Earth's perfect conditions. There's a different way to look at the silence, not as a mystery, but as a reflection of just how rare a place like Earth might truly be. This is the idea at the heart of the rare Earth hypothesis, that our planet is not simply lucky, it's exceptional, not in a philosophical sense, but in the raw configuration of its parts. A combination of factors that don't just support life, but make the existence of intelligent life incredibly difficult to repeat anywhere else. Start with our location. Earth orbits a star that burns with quiet stability. Not too hot, not too erratic. The sun has maintained its output long enough to allow life to grow slowly, over billions of years, without roasting the planet or going dim. But more importantly, Earth sits in just the right orbital zone, where water can stay liquid and where temperature swings are survivable. Too close, and oceans would boil. Too far, and they'd freeze. Then there's Jupiter. It may seem distant in our solar system, but its presence is anything but irrelevant. This massive planet acts like a gravitational vacuum cleaner, pulling in or flinging away asteroids and comets that might otherwise target Earth. Its orbit isn't perfect, but over the long term, it has shielded us from countless cosmic impacts. Without Jupiter's bulk drawing debris toward itself, our planet could have faced more frequent catastrophes, each one capable of wiping out whatever was trying to evolve. Now, look at the Moon. It's unusually large for a planet of our size. This isn't just a coincidence. The Moon helps stabilize Earth's axial tilt. That tilt controls our seasons. Without the Moon, Earth's tilt would wobble chaotically over time, swinging the climate between extremes. That instability would make it much harder for ecosystems to survive long enough for intelligence to emerge. The Moon also drives tides, which helped early life develop in dynamic coastal zones, wet, dry, and everything in between. Below our feet, the planet's engine is just as critical. Earth's interior is alive with movement. Plate tectonics reshape continents, recycle carbon, and regulate surface temperatures over geologic time. That movement releases heat, circulates minerals, and maintains a steady greenhouse effect. Not too much, not too little. Planets without tectonic activity may look Earth-like from a distance, but their atmospheres can grow thick with heat-trapping gases, or lose them entirely. And then there's the magnetic field, invisible but essential. Generated by the spinning molten metal core, it acts as a shield against solar and cosmic radiation. Without it, high-energy particles from the sun would strip away the atmosphere over time. Surface life would be bombarded with radiation. Water would evaporate into space. Conditions would shift from survivable to sterile. All of these features, Jupiter's position, the Moon's size, tectonic activity, a protective magnetosphere, are independent. But together they form a rare and fragile balance. Disrupt one, and the entire system shifts. Remove two, and the path to complex life narrows dramatically. That's what makes this idea so compelling. It doesn't argue that planets like Earth are impossible. It argues that the specific combination of factors that make Earth so stable, so temperate, and so long-lived might be almost never repeated. We search for exoplanets using our own world as the template. We look for the right size, the right temperature, the right chemical signatures. But maybe we're looking for worlds that only appear similar on the surface, when the deeper story lies in the details, in the subtle hidden features that make life not just possible, but sustainable for the eons it takes to become intelligent. So maybe the sky is quiet because the conditions that allowed us to listen in the first place are astonishingly rare. Not rare in principle, but rare in execution, a near-perfect sequence of planetary traits, all lining up in the right place, at the right time, under the right kind of star. If that's true, then the silence we hear is not a puzzle, it's a confirmation. And Earth is not just our home, it's the exception. Complex life may require a balance that rarely happens. It's one thing to find a planet that can host life. It's another to find one where life actually takes hold. But the biggest leap of all may be from life that merely exists to life that thinks. Single-celled organisms are tenacious. They can thrive in boiling vents, frozen ice, acidic pools. They don't need much, and once they appear, they tend to stick around. But complexity is different. Complexity demands structure, stability, time, and opportunity. The more intricate life becomes, the more conditions it depends on, and the more ways it can break. The development of complex organisms isn't guaranteed by habitability alone. It's not just about water and warmth, it's about a sequence of thresholds, each more demanding than the last. Multicellularity, specialization, nervous systems, eyes, limbs, memory, reproduction with variation. Each one opens new doors, but each one also adds another level of fragility. The path from microbes to mammals isn't just long, it's unpredictable. On Earth, it took nearly 3 billion years for simple cells to become anything more. For most of this planet's history, life was microscopic. The oceans were filled with invisible creatures, dividing and floating, without ever developing brains or bodies. Complexity, when it finally arrived, didn't explode outward. It tiptoed. Now, think about how rare that might be elsewhere. Even on planets with the right ingredients, those ingredients must persist, undisturbed, for an almost unimaginable span of time. Global extinction events, asteroid impacts, solar flares, unstable climates, any of these can halt progress. And when they do, evolution doesn't just pause, it resets. Millions of years lost in a single catastrophe. Even when complexity begins to emerge, it doesn't always aim upward. Life adapts to its surroundings, but not toward intelligence. There are many successful species that never needed to think in higher-order ways. Ants, jellyfish, fungi, they thrive by doing exactly what they've done for ages. Intelligence, in this context, is not a goal, it's a niche. One that may only arise when certain pressures, opportunities, and random events align just right. And then comes the brain, a structure so costly that most species never develop it. It uses a huge amount of energy. It demands a high-calorie diet. It requires a long developmental period and a social structure to protect the young. It's a biological gamble, and the payoff, while enormous, doesn't guarantee survival. It guarantees complexity, which often means more vulnerability. Now, stretch this thinking across the galaxy. Millions of planets might host life, but how many can maintain the tight balance needed to foster it from molecule to multicellular, from multicellular to mobile, from mobile to mindful? Each stage can be derailed. Each step forward can be undone by a change in temperature, a shift in atmosphere, or a single mass extinction event. The deeper truth is this: complexity is rare because it's expensive. Nature favors what works with the least effort. And simple life works. It fills niches, recycles carbon, endures the harshest conditions. Complexity, by contrast, is a slow, delicate climb. A house of cards built over eons. And only a handful of planets, if any, may have the right combination of time, protection, and luck to let it stand long enough to evolve curiosity. So, maybe that's what we're missing in our search. Not just planets with oceans or oxygen, but planets with history. Planets that had enough uninterrupted time to walk the full evolutionary distance. Not just a life, but a life that can ask questions. If that kind of journey almost never completes, then we are not early. We are rare. Not in where we are, but in what we've become. Cosmic timing. Life may be abundant, but intelligence is just beginning. There's a tendency to think of the universe as old enough for everything to have already happened. That if civilizations were out there, they should have already come and gone, risen and expanded, left their mark in some obvious way. But what if the silence we hear isn't a result of failure, but of timing? Not every clock runs on the same rhythm. Across the cosmos, stars are still being born. Planets are still forming. Some of the systems we now observe with telescopes are in their infancy. Others have only just cooled enough to support the chemical conditions needed for life. And while life may spring up quickly once those conditions are met, the evolution towards something that can think, build, and question, something that can look back at the stars and wonder, takes time. A long time. The ingredients for biology may be widespread. Simple organisms could be thriving across countless worlds. But the leap from survival to self-awareness is not just evolutionary, it's temporal. It depends on everything lining up: stability, protection, duration, and just enough pressure to drive complexity without extinguishing it. And that's a process that doesn't unfold overnight. It spans geological epochs. Our own planet offers a clear example. Earth formed more than 4 billion years ago. The earliest signs of life showed up shortly after, but those signs were microscopic, basic, and consistent for the vast majority of our history. For almost all of that time, life stayed simple. Only in the last sliver of Earth's timeline did intelligence arrive, and even then, it took the shape of a single species capable of language, culture, and technology. Now, widen that lens. If the emergence of intelligent life takes billions of years even under ideal conditions, then it's entirely possible that many planets are still mid-process. Not lifeless, but not yet intelligent either. They may be crawling with ecosystems, biological systems we wouldn't even recognize, early forms of neural activity, or collective networks just beginning to spark. They may be on their way towards sentience, but not quite there yet. Some planets might be at the bacterial stage. Others may be developing primitive animals or forming the building blocks of cognition. Each world follows its own pace, shaped by its star, its chemistry, and its collisions with chance. And if intelligent life only began blooming recently across the universe, then we may simply be hearing the quiet hum before the chorus begins. It's easy to expect the universe to be filled with empires and signals, to assume the skies should already be alive with activity. But we forget that even in places with promise, development takes time. Civilizations might not yet be advanced enough to build megastructures, launch probes, or broadcast signals that span light years. Some may have just discovered fire. Others may still be evolving language. Their existence wouldn't register on our instruments, not because they're absent, but because they're still becoming. This changes the way we think about the present. The silence we observe might not be the end of a story. It might be the beginning, a period of stillness before the galaxy stirs. We might be standing at the front edge of a wave, not isolated, but early enough to wonder if others will catch up, or if we'll be the ones they someday discover. And if timing really is the reason for the silence, then the question shifts. It's no longer, where is everyone? It becomes, how long until we're not the only ones listening? The universe may be too young for widespread civilizations. There's a kind of arrogance in assuming the story is already finished, that the universe has had all the time it needs to fill itself with advanced civilizations. But what if that belief misses something simple? What if the story hasn't had enough time yet? Not because life is rare, not because the barriers are impossible, but because the universe, for all its age, is still young in ways that matter most. Yes, the universe is nearly 14 billion years old. That sounds ancient, But the stars that formed early on were poor in the heavy elements needed to build planets like Earth. In the beginning, there was mostly hydrogen and helium, basic building blocks, but not the complex toolkit required for rocky worlds, oceans, or carbon-based life. It took generations of stars to fuse those heavier elements, explode in supernovae, and scatter that material across space. Only then could newer stars form with planets rich enough to support chemistry like ours. This process wasn't quick. It took billions of years for the cosmic ingredients to mature. Even now, many galaxies are still in the early stages of chemical evolution. Star formation continues. New systems are still forming around stars that didn't exist when Earth came to be, which means we might be seeing only the first wave of planets capable of hosting complex, intelligent life. And then there's the matter of stability. Civilizations don't grow in chaos. They need long stretches of calm to reach the level where they can leave a mark. But for a huge portion of the universe's early history, conditions were hostile. Galaxies were more compact, which meant more collisions. Radiation levels were higher. Explosions were frequent. Planets forming in those zones would have faced constant disruption. It's hard to evolve anything meaningful when your world resets every few million years. Only recently, on the cosmological clock, has the universe started to quiet down. Star systems have spread out. Explosive events have become less common. The rhythm has slowed enough for planets to cool, atmospheres to stabilize, and evolution to stretch its legs. In other words, the conditions that make civilizations possible may have only recently come into play. So, while the universe may be billions of years old, the window for widespread civilization may only now be opening. It could be that we're living in the early bloom of potential, not the late decay. A time when the seeds have only just started to take root in fertile soil. We may be standing at the very moment when intelligent life is beginning to emerge across thousands of worlds, but hasn't had time to make itself known yet. Signals may not be missing. They may simply not have left their planets yet. Megastructures may not be absent. They may still be sketches in someone's imagination. Galactic travel, if it's even possible, might still be a dream whispered in languages we'll never hear. In this light, the silence we hear isn't ominous. It's developmental, like walking into a vast theater moments before the curtain rises. The seats are filling, but the show hasn't begun. The civilizations are forming, but the dialogue hasn't reached us yet. If the universe is too young for widespread civilization, then this moment, right now, may be the quiet before the expansion. A fragile, formative era where stars are aligning, planets are stabilizing, and consciousness is beginning to surface in places we will never see. The absence of noise isn't always a sign of emptiness. Sometimes it's just the sound of something that hasn't spoken yet. We might be among the first, or the only. It's a question that feels too big for one mind to hold. What if we are not just early? What if we are the first? Not the first to build cities or reach space or split the atom. The first to look out from a small blue world and ask, seriously and collectively, whether anyone else has ever done the same. It's a heavy position to consider, that out of all the stars, all the galaxies, all the chances for life to begin and grow and question its place, we were the first spark to light. This isn't a theory meant to soothe or frighten. It's a scenario with consequences. Because if the universe has only recently become capable of supporting civilizations like ours, and if the filters that destroy them haven't yet closed in, then it may be that we've arrived before the others. Not because of special destiny, but because of statistical placement. Someone had to be first. Someone had to cross the threshold from biology to thought, from instinct to intention. Maybe it was us, Being first doesn't mean best, it doesn't mean chosen, it just means early. The earliest tree in a forest still stands alone, even if others will come. But while it stands, it bears all the wind, all the exposure, all the unknowns without a pattern to follow. That's what it means to be the first intelligence aware of itself in a quiet cosmos. There is no blueprint, no mentor, no signal to answer. And then there's the harder truth. What if no one else is coming? What if life is widespread, but it never reaches the complexity we have? What if Earth is not only rare in its composition, but unique in its outcome? What if intelligence, despite all the ingredients out there, remains a fluke, a once-in-eternity burst of awareness in a universe otherwise indifferent? That's a position that demands more than humility. It demands responsibility. Because if we are the only civilization to ever reach this point, or the first of very few, then the choices we make here, now, matter on a scale that's hard to comprehend. The survival of knowledge, of memory, of meaning, it might rest entirely on us. What we preserve, what we pass on, what we destroy. These decisions may not echo into a galactic society. They may be the only record this universe will ever hold of a species that knew what it was. There's nothing romantic about being alone at this level. It's not grand, it's not glorious, it's sobering. It means that our wars, our errors, our short-sightedness and our brilliance are not just human, they are cosmic, because they might never be repeated. If we vanish, it may be millions or billions of years before another species finds its footing, if it ever does. To be first is to build without help. To be alone is to hope without reassurance. And yet, here we are, still asking, still looking, still daring to believe that we are not the final word, but the opening sentence of something greater. And if we are the first, then it's not just our survival that matters. It's what we do with the silence. They're already here. UFOs, UAPs, and government disclosures. The official glimpse into the unknown. There's been a shift. For decades, talk of unidentified flying objects sat on the edge of conversation. Half curiosity, half conspiracy. But recently, the language changed. What was once dismissed has now been reclassified under a new label: Unidentified Aerial Phenomena, or UAPS. And more importantly, the conversation is no longer just happening in fringe communities. It's happening in government hearings, military briefings, and national security reports. It started quietly, in ways that didn't make headlines. A few leaked videos. A few grainy frames showing fast-moving objects with no visible propulsion, no wings, and no exhaust. Just speed control and behavior that defied known technology. The footage wasn't from amateurs in backyards. It came from trained military personnel, pilots with thousands of hours of experience, radar operators, naval sensors, eyes and instruments that are trusted in combat, now pointing to something they couldn't explain. What stood out wasn't just the visuals, it was the patterns. Objects appearing at altitudes no aircraft could sustain, accelerating instantly, turning sharply without losing speed, and hovering in place without a source of lift. These weren't balloons drifting on the wind. They moved with precision. They responded to approach. They avoided interception. And they left behind signatures on multiple systems: video, radar, infrared, all capturing the same events in real time. Eventually, it became too consistent to ignore. The U.S. government responded not with dismissal, but with acknowledgement. For the first time in modern history, agencies officially confirmed that, yes, there are objects in our skies that defy explanation. Not myths, not misunderstandings, but verified encounters logged by defense systems and observed by professionals. In 2020, a formal report was submitted to Congress. It didn't speculate on origin, motive, or design, but it did confirm over 100 documented incidents that couldn't be traced to any known military or civilian technology. Some of these incidents were recorded over sensitive installations, restricted airspace, nuclear facilities, and in many cases the objects didn't just appear, they returned. The response wasn't fear, it was focus. Committees were formed, programs expanded. Classified data began to filter into public discussion. High-ranking officials, once silent, spoke on record. Not to say we know what this is, but to admit plainly, we don't. And that admission, coming from the highest levels of defense infrastructure, marked a turning point in the global conversation. For decades, the topic had been shaped by dismissal and ridicule. But now, the language is clinical, strategic, measured. "We don't know" became an official position, backed by data, sensors, and testimonies. It's not proof of extraterrestrial presence, but it is proof of something else, something flying, maneuvering, and observing in our skies with capabilities far beyond anything we've publicly built. And for the first time, the world's most powerful institutions aren't laughing it off, they're taking it seriously. This forces us to rethink the question of visibility. Maybe the signals we've been waiting for were never going to come from the stars. Maybe they've already come, and we just didn't recognize them. Or worse, we recognized them and looked away. Because when something enters your airspace without explanation, behaves beyond your limits of engineering, and disappears without a trace, silence is no longer a mystery. It's a strategy. Allegations of crash retrievals and secret programs. There's another layer to this story. One that doesn't come from sensors or telescopes, but from voices behind closed doors. Testimonies. Leaks. Whispers too persistent to ignore. For years, rumors have circled through the darker corridors of government and defense circles that unidentified objects haven't just been seen, but recovered. Not glimpsed in the sky, but pulled from the ground. Allegations of crash retrieval programs have surfaced again and again. Some say they're old. That wreckage from unknown craft was quietly gathered decades ago, hidden under layers of classification. Others claim it's ongoing. That pieces of something not built by human hands are being studied in specialized facilities, off the books, behind secure vaults guarded not just by fences, but by silence. These claims don't come from science fiction writers or late-night radio callers. They come from former intelligence officers, aerospace insiders, and defense contractors who speak cautiously, often with carefully chosen words. They don't offer wild stories. They offer patterns. Patterns of compartmentalization, off-limits access, and buried funding streams. Details that suggest something is being shielded from public view. The consistent thread in these reports is the existence of materials not identifiable by any known industrial or military process. Metals that exhibit unusual isotopic ratios. Components that resist reverse engineering. Structures that seem to defy the known laws of propulsion or inertia. Whether these are misinterpretations, misdirections, or misunderstood prototypes is still unclear. But the allegations persist. Some describe debris, fragments pulled from impact sites and carefully catalogued. Others speak of intact vehicles, controlled recoveries of objects that didn't just fall out of the sky, but arrived, malfunctioned, and were seized. There are even claims that attempts have been made to power or activate these craft, often with frustrating results. Power systems that won't respond. Structures that don't behave like any mechanical device. Interiors with no controls, no seats, no clear origin or purpose. The programs that allegedly house this research are said to operate beyond oversight, hidden not only from the public, but from elected officials, intelligence agencies, even top military leadership. Access is tightly restricted. Information is fractured. Need-to-know compartments are built so narrow that few, if any, hold the full picture. And yet, every few years, something leaks out. A memo, a transcript, a sworn statement under legal protection. Enough to keep the discussion alive. Enough to make us ask, if these allegations are baseless, why do so many qualified individuals keep risking their reputations to raise them? Whether these craft are alien in origin or misunderstood technology is a separate debate. What matters here is the claim that physical encounters have occurred, that we are not just observers. We are custodians of objects not made on Earth and not yet understood. These allegations, if ever proven true, would reframe every question we've asked so far. The silence we perceive would not be due to distance or absence. It would be due to containment, not by the stars, but by ourselves. And in that silence, the most advanced message might not be a transmission from another world. It might be the shape of something already hidden beneath our own. Skepticism versus credibility. Is it truly alien or advanced human tech? In any search for truth, the line between belief and proof is where the real tension lives. When unidentified objects appear in our skies, maneuvering at speeds that seem to outpace physics, shifting direction with no visible propulsion, and vanishing without a trace. The first question isn't what are they, it's who built them. And that's where skepticism and credibility collide. Skeptics argue from the ground up. They don't accept a leap to alien technology without exhausting every Earth-based explanation first. That's not cynicism, it's discipline. It means asking whether the objects could be advanced drones, foreign military prototypes, classified aerospace projects, or experimental platforms decades ahead of what the public sees. After all, technological progress doesn't stop where public knowledge ends. There are machines flying today that won't be declassified for years, if ever. But then the data piles up. Trained military pilots reporting high-speed interceptions of objects that outperform their jets, infrared signatures showing movement without heat, radar locks lost instantly without atmospheric turbulence, multiple sensor systems confirming the same object from different angles at the same moment. Not one glitch, not one misreading, but repeated, consistent anomalies over oceans, deserts, training zones. From people trained not to exaggerate but to report with precision. Credibility comes not from the phenomena itself, but from the pattern of evidence across separate domains: visual, thermal, radar, eyewitness. When each piece confirms the other without overlap, it begins to form a picture that's hard to dismiss with convenient explanations. These aren't isolated lights in the sky. They're craft, structured, behaving with intent, with flight profiles no nation has officially disclosed. Some argue that if this were truly alien, there would be clearer signs: communication, contact, disruption. But that's assuming intention. If these craft aren't ours and yet move with intelligence, the absence of open interaction doesn't mean they're not real. It might mean their goals aren't designed to align with ours. Or worse, it might mean we are not meant to understand them yet. Skepticism becomes more difficult when those who report the events have nothing to gain and everything to lose. Decorated veterans, seasoned radar technicians, aerospace engineers, all risking careers to step forward with details that don't fit inside any current box. They're not seeking answers. They're demanding accountability. Why are these objects operating in restricted airspace? Who controls them? And if we don't know, then who does? It's possible that what we're seeing are breakthroughs in human innovation, test beds for technologies so advanced that they mimic the impossible. If that's the case, it opens another troubling path. Are these developments under private control? Are they foreign? Are they beyond oversight? Because if they are man-made and still beyond the reach of any known system of accountability, the silence becomes even more dangerous. But if they're not ours, if they operate with principles outside of aerodynamics, outside of propulsion, outside of human design, then skepticism isn't caution anymore. It's a shield against something we don't want to face. Because the moment we accept that something non-human is here, the ground beneath our understanding shifts. Skepticism has its place. It keeps the wild claims in check. But when credibility outweighs doubt, when experienced voices, hard data, and repeatable evidence all point to the same unknown, then skepticism must evolve. It must stop asking if the stories are too strange to believe, and start asking why something so strange is happening in the first place. The silence isn't just in space. It's in the way we treat the questions right in front of us. Not because we don't have answers, but because we're still too afraid to follow them all the way through. Ancient aliens and hidden evidence, historical artifacts and myths, pointing to extraterrestrial contact. Across deserts, jungles, and mountaintops, the Earth holds more than bones and ruins. It holds patterns, strange alignments, symbols that repeat across cultures that never met, technologies buried in places that should not have known such precision, legends passed down through generations that speak not just of gods and spirits, but of beings who came from above, changed everything, and then vanished without a trace. The deeper we dig, the more we uncover stories that blur the line between myth and memory. Massive stone structures cut with atomic-level accuracy. Cities built on alignments that track celestial events with a level of astronomical understanding we only recently rediscovered. Monoliths moved across impossible terrain, with no clear explanation of how such weight was transported or lifted in the age before wheels, cranes, or engines. In Mesopotamia, Sumerian texts speak of visitors from the stars, figures described not as deities but as instructors. In ancient India, epic poems describe flying machines, craft engaged in warfare, moving through the sky with detail too vivid to be purely symbolic. Across the Americas, carvings and tablets depict figures with strange helmets, seated in positions that look eerily like modern astronauts. Were these just metaphors, or were they attempts by early civilizations to describe something real, using the only language they had? Even more puzzling are the artifacts. Carvings in pre-Columbian gold shaped like delta-winged aircraft. Batteries discovered in clay jars buried beneath sand, dated centuries before electricity was supposed to be understood. Maps drawn during the Age of Sail showing Antarctica's coastline free of ice, something satellite imaging only recently confirmed. And yet, there are no written records explaining how these were created. No instruction manuals, no prototypes, just final products, perfect and complete, with no signs of iteration. That absence of developmental evidence raises a haunting question. Were these technologies native to the people who possessed them, or were they remnants of something they merely observed? Throughout history, nearly every major civilization has described encounters with beings who descended from the sky. They are described as radiant, powerful, otherworldly, but also as flesh and blood. Often they arrive in craft. Often they offer knowledge, medicine, architecture, astronomy, and then depart, promising to return. These similarities stretch across continents and centuries, not in the broad strokes, but in the details. Descriptions of flying discs, beams of light, fireless chariots, soundless movement, devices that change weather, languages unknown, skin that glowed. In many accounts, they came not to conquer, but to instruct, not as invaders, but as temporary custodians. Skeptics may call these stories allegory, but the precision of some accounts and the physical clues left behind raise the possibility that they weren't fabrications, but flawed interpretations of events that really happened. Ancient people may not have had the framework to understand what they witnessed, but they preserved what they saw the best way they could, through carvings, oral tradition, and monumental architecture. Over time, those stories calcified into myth. As generations passed, details faded, gods replaced visitors, symbols replaced systems. But beneath the mythology, traces remain, and the pattern they form doesn't point downward, it points up. If true, this reframes the entire question of contact. It suggests we're not waiting for a first encounter, we're living in the shadow of a second. That what we call ancient might not just be distant in time, but obscured by the failure of memory and the erosion of proof. The silence of the stars may not be due to absence, but to the fact that the signal already arrived long ago, and we turned it into a story. Are we misinterpreting religious or mythological accounts? For much of history, the way humanity recorded extraordinary events was not through logs or technical diagrams, but through story. Before science, there was symbolism. Before explanation, there was belief. And so, when something unexplainable happened, it was woven into the language people understood best: gods, spirits, angels, and demons. But what if some of those stories weren't metaphor? What if they were memory, filtered through time, culture, and limited understanding? Throughout ancient texts, religious scriptures, and mythic traditions, there are moments that stand apart from the rest. Sudden descents from the heavens, blinding light, beings arriving in radiant form, not walking the earth but descending from above, bringing messages, laws, warnings, or judgment. Some arrive in wheels within wheels, some in clouds that glow without fire, some with wings that do not move. They speak in voices that terrify entire armies. They vanish as quickly as they appear. These stories are scattered across cultures with no connection. From the highlands of Central America to the sands of the Middle East, the mountains of Japan to the plains of Africa, the motifs repeat: luminous visitors, strange crafts, unnatural light, noise without sound, fire that doesn't burn. Stories that speak not of war or conquest, but of something alien in the literal sense of the word, something not from here. Many of these accounts involve sky-bound entities who descend not to kill or conquer, but to instruct. They deliver knowledge, issue commands, give blueprints, warn of floods or disasters. They are often described as taller, brighter, and physically different from any human, and yet their behavior is deliberate, their timing precise. To an ancient shepherd, a machine is a miracle. A descending craft to a desert tribe may look like a divine chariot. A figure wrapped in a pressurized suit could become a god or an angel. Lacking the vocabulary to describe what they saw, people reached for what they had: spiritual language, mythic reference points, sacred metaphors. That lens shaped the way these encounters were remembered. But within those religious and mythological narratives, there may be a core of events that were never meant to be symbolic. They may have been encounters, real, tangible, and misunderstood. If even a fraction of these stories were rooted in literal experience, then the evidence for extraterrestrial contact may have been in front of us all along. Not in the sky, but in Scripture. Not in technology, but in theology. Of course, that blurs uncomfortable lines. It raises questions about the origin of belief, the nature of inspiration, and the foundation of some of the oldest institutions on Earth. But those questions must be asked because the details are too consistent to ignore, and it may explain why so many stories speak of a return, a promise that the visitors would come again, not in a distant afterlife, but in real time, on Earth, in fire or cloud or sound. That thread of expectation runs through more than one religion and in more than one language. Not metaphorically, literally. So, perhaps the silence we struggle to understand is not because there's been no contact. Perhaps we've already been contacted and turned it into worship. Why mainstream science rejects these claims, and where the evidence falls short. In science, certainty is earned, not assumed, and when claims emerge that rewrite everything we think we know about life, history, or the universe, the burden of proof grows heavy. That's why, when talk of extraterrestrials, ancient contact, or recovered crafts enters public discussion, mainstream science often responds with resistance. Not because it isn't curious, but because it demands a level of evidence that many of these claims fail to meet. The structure of the scientific inquiry is built around repeatability, transparency, and control. You make a claim, you show your data, and others must be able to test your results independently. If a discovery can't be duplicated, or if the method used to reach it isn't open for inspection, it doesn't matter how compelling the conclusion feels. It gets set aside, not silenced, just held to the side until something more concrete is brought forward. That's why stories of unidentified aerial phenomena or alleged crash retrievals often stall at the threshold of academia. The evidence, in many cases, is anecdotal. Eyewitness reports, second-hand accounts, restricted access documents. These aren't nothing, but they fall short of what science considers actionable proof. Testimonies, no matter how credible the source, can't be calibrated. They can't be run through simulation or analyzed for error margins. Without physical materials to examine, without instruments to replicate the event, science is left with a story that can't be verified. And that's not enough. Then there's the problem of chain of custody. Many artifacts said to be linked to non-human craft or ancient technologies are either untraceable or locked away from peer review. If an object is discovered, it must be handled in a way that preserves its origin, age, and context. If that trail is broken, if the material changes hands, is tampered with, or lacks clear documentation, then its value as evidence diminishes, regardless of what it appears to be. Science also operates under certain thresholds of plausibility, not because it's rigid, but because it requires consistency with everything else we already know. If a new claim contradicts the laws of physics, it must either present a new framework or be so overwhelmingly supported that it forces a rethink of the old one. This is not a dismissal of the unknown. It's a safeguard against accepting something just because it's exciting. The history of science is full of theories that were once rejected, but later proven true. But they were proven, not presumed. This is where the gap widens. Proponents of alien contact often frame science as closed-minded, but from within, science sees itself as cautious. It isn't hostile to paradigm shifts, it just refuses to leap into them without enough weight behind the evidence. That's not fear, that's discipline. Because accepting a false positive, something that looks incredible but turns out to be incorrect, does more harm than waiting a little longer for something that can hold up to scrutiny. That said, there are legitimate criticisms of how certain topics are handled. Dismissing entire fields of inquiry without review. Ridiculing individuals instead of evaluating their claims. These are not scientific responses. They are social ones, based in bias, fear of ridicule, or institutional inertia. And when the scientific community fails to separate bad data from unpopular questions, it contributes to the very secrecy and stigma that hinders progress. The evidence presented for alien contact often relies on fragments, pieces that, on their own, are curious but incomplete. Radar footage with missing metadata, photos with unclear provenance, testimonies with no supporting documentation. These pieces may point to something unknown, but without the full picture, science cannot move from curiosity to conclusion, and that's where the conversation stalls, between the need for rigorous validation and the allure of the extraordinary, between cautious skepticism and the yearning for something more. The silence from mainstream science, then, is not always denial. Sometimes it's a placeholder, waiting for something that hasn't arrived yet, not because it doesn't exist, but because no one has brought it forward in a way that the system can examine without compromise. Until then, science stands on the edge, open but unmoved, watching, waiting, and reminding us that even the most extraordinary truths must first survive the simplest question: can this be shown? SETI and radio silence. What SETI has been doing since the 1960s. There's been a constant hum beneath the surface of human progress. A quiet, tireless scan of the sky that began decades ago, far from headlines, far from spectacle. Since the 1960s, SETI, the search for extraterrestrial intelligence, has been methodically pointing radio telescopes at the cosmos, waiting for something most people will never hear. The flicker of a signal that says, "We're not alone." SETI wasn't born out of fantasy. It was rooted in a simple idea. If we're here, broadcasting signals from Earth, radio, television, radar, then it's reasonable to think that another civilization might be doing the same. Not with lasers or spacecraft, but with energy. Information sent through the electromagnetic spectrum. A voice traveling across light years, not aimed at us, but drifting across space the same way ours does, without intent, just momentum. The early efforts were modest. One antenna, one computer, one sky survey. It wasn't about volume, it was about patience. Operators picked a patch of sky, tuned their instruments to a quiet frequency and listened. Not for hours, for months. Some programs scanned a single frequency for years, waiting for even a whisper of artificial origin. Over time, the search expanded. More observatories joined. New instruments came online. Algorithms grew more sophisticated, designed to filter out Earth-based interference, satellites, military radar, and natural sources like pulsars and quasars. The goal was simple: detect a narrowband signal, a spike in the noise that stands out not because it's strong, but because it's structured. The vast majority of the data returned was silence, long, flat graphs with no variation, datasets that ran for terabytes, revealing nothing more than the quiet hiss of the galaxy. But this wasn't failure, it was information. Every patch of sky ruled out, every frequency scanned, narrowed the mystery. It told us where the answer wasn't. And in science, that's progress. SETI never promised a quick discovery. From the beginning, it understood that the odds were small. The number of stars is enormous, the number of frequencies infinite, and the window for overlapping civilizations might be heartbreakingly brief. But still, the work continued, systematically, meticulously, without fanfare. Not because they expected immediate success, but because the alternative was to sit in silence and do nothing. SETI's real contribution wasn't just the listening. It was the discipline, the refusal to jump to conclusions. Every spike was triple-checked, every anomaly was traced. Equipment was tested, retested, ruled out. This was not a program looking for headlines. It was a process grounded in rigor. And that rigor made its absence of discovery even more profound. It's one thing to say we haven't heard from anyone. It's another to prove you've been listening. SETI has been listening, day after day, year after year, with tools precise enough to hear a whisper from 1,000 light years away. And still, nothing. That silence became a clue of its own, a silence so consistent that it shaped the very way we asked the question. If the universe is speaking, why is it speaking so softly? Or worse, why isn't it speaking at all? SETI's search was never passive. It was a declaration that if there was someone out there to hear, we were ready to listen. And in listening, we told the stars something important. Not just that we exist, but that we care. And even if the silence continues, that act alone might be the beginning of something. Notable efforts. Wow. Signal. Breakthrough. Listen, not all silence is empty. Sometimes it's interrupted, not by a pattern, but by a single note that stands out so sharply it forces everything to stop. In the long, tireless history of searching for extraterrestrial signals, only a few moments have ever come close to disrupting the stillness. Among them, 2 efforts stand as milestones. One was sudden, the other systematic. Both have shaped how we measure possibility. In 1977, a narrowband signal struck a radio telescope in Ohio. It lasted just 72 seconds. No follow-up, no repetition, but the spike was so clean, so far above background noise, and so well-defined that it was unmistakably different. One astronomer circled the data printout and wrote a single word in the margin: "Wow." And it stuck. The wow signal became one of the most famous anomalies in the history of SETI. It came from a patch of sky near the constellation Sagittarius, close to the galactic center. The signal matched the kind of frequency scientists expected a technological civilization might use. It wasn't noise, it wasn't random, and for all the data recorded since, nothing quite like it has ever been heard again. There was no encoded message, no modulated signal, just a brief, perfect rise in strength, then gone. Attempts to detect it again have all failed. Some believe it may have been a reflection, a classified transmission, or an unrepeatable glitch. But decades later, no one has provided a solid explanation. It remains the closest brush we've had with something that felt deliberate. While the wow signal was fleeting, breakthrough listen is the opposite. It's long-term, broad. A $100 million initiative launched to scan the stars with a depth and scale no previous effort had achieved. Thousands of stars are being observed across billions of radio channels using some of the most sensitive equipment on Earth. This isn't a passive wait, it's an aggressive reach. The project doesn't rely on guesswork. It's mapping regions where planets are known to exist, listening across vast portions of the radio and optical spectrum, capturing terabytes of data every day. Every spike, every signal, every flicker is logged, checked, categorized. What makes breakthrough listen so important isn't just the equipment, it's the rigor. Every anomaly is analyzed with the intention of ruling out Earth-based interference first. The assumption isn't that aliens are contacting us, it's that we have to eliminate every other possibility before even suggesting it. But the data is building, slowly, steadily, across years of observation. Thousands of hours of signal analysis have produced candidates. Signals that stood out briefly, but under review collapsed into noise. Not because they were wrong, but because they didn't repeat. And repetition is everything. Without it, a signal is just a ghost in static. Still, the effort presses on, and the silence it encounters isn't failure, it's a canvas. Because if anything is out there, broadcasting, even by accident, breakthrough listen is one of our best chances to catch it. And if nothing is found, then at least we'll have mapped vast swaths of silence with more certainty than ever before. The wow signal was a moment. Breakthrough. Listen is a commitment. Together, they represent the arc of our curiosity, from sudden possibility to disciplined pursuit. And through both, we've learned that listening is more than just waiting. It's about attention, precision, and the willingness to hear everything, even when nothing speaks back. Why we may be listening on the wrong frequencies or missing narrow signals. For all the effort poured into listening, we may have made one quiet mistake from the very beginning. We assumed we knew how they'd speak. Radio waves were a logical starting point. They're efficient. They travel far. They can pass through interstellar dust, and they've worked well for us here on Earth. But basing the search for alien intelligence on our own habits may be the very thing that's keeping us deaf. The electromagnetic spectrum is vast, far broader than what human senses or even most instruments can detect in a single sweep. What we call radio is just a narrow slice of that spectrum, and even within that range, we only listen to certain parts. Frequencies we think are quiet, frequencies that don't overlap with Earth's noise. But if a civilization chose to transmit differently, higher, lower, pulsed, compressed, or encoded in ways we've never conceived, our antennas would register nothing at all. Not static, not noise, just silence. Then there's the question of intent. We assume others might broadcast widely, aiming to be found. But what if they're not? What if their transmissions are tight-beamed, focused only at specific targets? Or what if they use narrowband pulses that only flash for microseconds at intervals we've never thought to check? A signal like that could pass right through our detection windows, buried in our blind spots, never triggering a flag, never catching attention. Even more likely is the possibility that advanced civilizations don't use radio at all. That what we consider communication is already outdated by their standards. They might be using something beyond our current understanding: quantum entanglement, neutrino signaling, gravitational waves, or completely unknown forms of data transmission that we haven't developed instruments to even recognize. If the method itself is outside our framework, then it wouldn't matter how long we listened or where we pointed the dish. We'd miss the conversation completely. There's also the question of timescale. A signal might last minutes or milliseconds. It could repeat once a year, or once every 10,000. If our instruments aren't watching the right point at the right time, it would go unnoticed. And since we can't monitor every star continuously, we're left with snapshots, fleeting moments of observation amid a constantly changing sky. It's like listening to a single note in a massive symphony and assuming there's no song. Even when we do detect something that looks anomalous, brief bursts, fast radio flashes, strange pulses, they're often dismissed. Natural phenomena can mimic artificial signals. Pulsars, quasars, magnetars, they produce rhythmic, energetic waves. And in the absence of repetition or pattern, it's safer to file them as natural. But what if something artificial could hide within that noise? What if buried in a pulsar's rhythm is a modulated pulse, a signature of intent camouflaged by the very mechanisms we expect from nature? Another factor is encryption. If another civilization encrypts its transmissions, even a perfectly received message would look like meaningless noise unless we had the key. And without context or common reference, there would be no way to decipher it. A message could be screaming across the stars right now, perfectly structured, deliberate, and we'd call it background radiation because we can't recognize its design. It's also possible that they're using systems that don't even attempt to reach us, that their communication is inward, planet to planet or ship to ship. contained, private, never meant for external contact, and in that case, we wouldn't even be listening on the wrong frequency. We'd be listening to the wrong kind of conversation. All of this suggests that the silence we hear may not be silence at all. It might be signal, misunderstood, misplaced, or simply missed. A failure not of science, but of assumptions. Not of equipment, but of imagination. We may not be alone. We may just be tuned to the wrong station, with the volume set too low. Technosignatures and advanced detection. Dyson spheres, megastructures, atmospheric signatures. Some civilizations might not speak with sound or a signal at all. They might leave their mark in how they reshape their world or their star. And if we know what to look for, we don't need to hear them to know they exist. We just need to watch carefully enough for their fingerprints. This is where technosignatures come in. Not a signal in the conventional sense, but a trace. Evidence left behind when technology reaches a scale that's impossible to hide. It could be as subtle as a chemical imbalance in an alien atmosphere, or as colossal as a star behaving in a way that defies the laws of nature. Either way, these signs don't require intent. The civilization might not even know we're looking. But if they're there, they're changing their environment, and those changes can be detected from across the galaxy. One of the boldest examples is the concept of a Dyson sphere. Not a solid object, but a swarm of structures orbiting a star to harvest its energy. Imagine, not in a poetic sense, but in sheer engineering terms, the scale of such a project. Billions of collectors, each positioned to capture sunlight and convert it into usable power. Such a structure wouldn't glow. It would dim the star, absorb light, and re-emit waste heat in the infrared. From Earth, it would look like a star growing fainter, redder, not by natural causes, but because something was consuming its energy. We've built simulations to model what such a system might look like. We know the kind of spectrum it would produce, the light curves it might distort, the thermal signature it would leave behind. If someone built a Dyson swarm, even halfway through completion, we might notice it not as a flashing beacon, but as a star that doesn't behave like the others. A star that flickers or fades not because it's dying, but because it's being used. Then there are megastructures closer to planetary scale. Artificial rings, orbital habitats, massive arrays of satellites. These wouldn't need to block out a star to be noticed. They might change a planet's reflectivity, affect its transit profile, or interfere with its thermal emission. Instruments sensitive enough to observe these changes wouldn't see alien architecture directly, but they'd notice the signature it leaves in the data. Some signs are even smaller. Atmospheric signatures, for instance. Life changes air, it does here on Earth, and we expect it to elsewhere. Oxygen, methane, ozone, these are chemical markers that often indicate biological activity. But advanced civilizations might leave behind synthetic chemicals too. Industrial waste, fluorinated gases, rare isotopes that don't occur in nature. These wouldn't just suggest life. They would suggest industry, machines, factories, activity far beyond what biology alone would produce. What makes this search so powerful is that it doesn't rely on cooperation. A civilization doesn't need to transmit or respond. They don't need to know we exist. If they build big enough or change their planet enough, the laws of physics guarantee some part of that action becomes visible. Light shifts, heat radiates, chemicals scatter. And in those subtle changes, the presence of intelligence becomes legible across the void. The challenge, of course, is not the concept, but the scale. Our instruments are just beginning to reach the sensitivity needed to notice these anomalies. Telescopes that can filter out a single spectrum from a distant star. arrays that can measure heat signatures from a planet tens of light years away. The precision required is staggering, but it's coming. And when it does, the search for life may not be about catching a message. It may be about reading a blueprint written in light, the orbit of a collector, the haze of a chemical that shouldn't be there, a star with energy being used instead of wasted. If civilizations are building somewhere out there, then their tools, no matter how silent, will cast shadows, and shadows eventually reveal shape. Tabby's star and other anomalies. There are stars in the sky that behave like nothing else we've seen. Stars that flicker, not with rhythm, but with chaos. One of them, more than any other, has stirred both excitement and confusion. A single light in the constellation Cygnus that dimmed in ways no natural explanation could fully satisfy. That light is Tabby's star. For a long time, its behavior made no sense. Unlike the clean, symmetrical dips in brightness caused by orbiting planets, Tabby's star would dim without pattern, by a few percent, then by 20, then barely at all. The intervals were irregular. The duration varied. No other star, out of the hundreds of thousands observed during that period, behaved this way. At first, theories leaned toward dust, clouds of material passing between us and the star, but the spectrum didn't shift as expected. Then came the possibility of comets, large swarms in unpredictable orbits, but the quantity and timing didn't add up. Other theories tried to connect it to intrinsic fluctuations within the star itself, but none could explain the magnitude and randomness of the dimming. And so, almost reluctantly, a new idea entered the conversation. Perhaps what we were seeing wasn't natural at all. Tabby's star became the first real-world object discussed seriously, even within scientific circles, as a potential example of an alien megastructure. Not because there was proof, not because it looked artificial, but because every natural theory left gaps, and the idea of massive irregular structures orbiting the star, perhaps harvesting energy, could, in theory, explain what was happening. Even if that wasn't the answer, the event pushed open a door. It showed that we should not always expect artificiality to announce itself with clean geometry or repeating signals. Some civilizations might build in ways that blend into the irregularity of nature, or whose structures evolve over time, growing less efficient, more chaotic. What if we're looking at ruins, not functioning systems? Broken fragments of a project abandoned long ago. And Tabby's star isn't alone. Other stars have exhibited behavior that sits just outside the comfort zone of conventional astrophysics. Some dim sharply and then return to normal without a trace. Some pulse in irregular rhythms, inconsistent with their class or composition. Some shift color without cause. These aren't signals in the traditional sense, but they are disruptions in expectation. And if we're serious about the search for intelligence, we can't afford to dismiss disruptions just because they don't fit a clean theory. Most of these anomalies likely have natural explanations waiting to be discovered, but not all of them will. And if even one is artificial, if even one is the footprint of technology, lost or active, then it means we've already found the sign we were looking for. We just didn't recognize it. That's the challenge of a silence that might be deceptive. Because if we expect aliens to speak with radio waves and blinking lights, we may overlook the quiet, massive, slowly changing canvases they leave behind. Stars that should not flicker, but do. Heat signatures that should stay constant but drift. Shadows that return where no planet orbits. It's possible the greatest messages aren't encoded in patterns but in puzzles. Not in the things we hear, but in the things that don't add up. Maybe alien civilizations don't use radio at all. What about quantum or neutrino communication? Radio has served us well. It's helped us navigate oceans, broadcast voices across continents, and speak to machines on other worlds. But we built it for us. It fit our tools, our scale, and our moment in time. The assumption that others would do the same may be the flaw that shaped the entire silence. Because if a civilization is thousands or millions of years ahead, they may have moved far beyond radio long ago. Their methods of communication could look nothing like ours. They may not need antennas or transmitters. They may not even use waves that we've learned to detect. And if that's the case, then everything we've been listening for might be entirely out of tune with the actual song. Quantum communication is one possibility. It doesn't rely on waves at all, not in the traditional sense. It works through entanglement. Two particles separated by any distance, sharing a state so intimately that when one changes, the other responds instantly. No delay, no need to cross space, no signal that travels in the way we understand movement. If this principle can be scaled, it offers a method of communication that is instantaneous, faster than light, immune to interference, and undetectable unless you're one of the intended recipients. But quantum systems aren't noisy. They don't scatter. They don't fill the air with static. If a message is being sent this way, there's no bleed, no background hum. You either receive it or you don't. That would make it the perfect medium for civilizations that value privacy or efficiency. From the outside, it would be invisible. We could be surrounded by conversations, layered and infinite, and we would never hear a whisper. Neutrino communication presents another angle. Neutrinos are subatomic particles with almost no mass. They barely interact with matter. Trillions pass through your body every second without a trace. They're incredibly difficult to detect, but they travel vast distances without scattering or being absorbed. A civilization that mastered the ability to encode information in neutrino bursts could transmit across the galaxy without worrying about dust, gas, or electromagnetic noise. From a practical standpoint, neutrinos are close to perfect. They don't announce themselves. They're almost impossible to block. And they allow for communication across space with minimal signal degradation. But that very strength is what makes them hard to catch. Building detectors sensitive enough to parse out patterns in neutrino streams is a challenge far beyond our current reach. We have devices that can register high-energy neutrinos, but not the subtle signatures a message would carry. If someone is speaking this way, we're not just missing the words, we're blind to the language itself. These methods would also solve another problem: intent. They allow for secure, targeted communication. No need to broadcast endlessly into the void, hoping someone is listening. No waste, no trail. Just clean, silent, deliberate exchanges between those who already know each other exists. From that perspective, the lack of signals becomes a feature, not a bug. To us, silence feels like absence. But in systems like these, silence might just be protocol. These civilizations may have evolved past the need for loudness, or they may have deliberately chosen quiet, a form of communication that doesn't light up sensors, doesn't leave a footprint, doesn't echo across centuries like a radio wave might. The truth is, we've been building radios and telescopes like people cupping their hands and shouting across a canyon. But what if the others have long stopped shouting? What if they found a way to speak without sound? If quantum links and neutrino channels are the standard, then we haven't just been listening in the wrong direction. We've been speaking a language no one uses anymore. And in that case, the silence isn't theirs. It's ours. Simulation theory. What if we're in a simulation that doesn't include aliens? There's one explanation that doesn't require silence in the stars, extinct civilizations, or advanced cloaking technologies. one that doesn't ask why aliens aren't contacting us, but rather, why we expect them to be part of this universe at all. What if they were never programmed into it? Simulation theory suggests that what we experience as reality may be an artificial construct, a simulation, designed with intent. The laws of physics, the structure of matter, even the passage of time, everything we take as fundamental may instead be parameters, adjustable, configured, defined by an outside architect. And if that's true, then the absence of other civilizations might not be a cosmic mystery. It might be a design choice. Within our world, complexity arises from simple rules. We see patterns, growth, evolution. We assume these things happen because they must. But if we are inside a closed system, an engineered reality, then what we call natural processes may not extend beyond us. The universe could be vast, yes, but it could also be limited in ways that aren't visible from within. A simulation doesn't need to render every possibility. It only needs to give the appearance of completeness to the ones experiencing it. In that case, the stars may not be empty because life failed to emerge. They may be empty because no other life was ever written into the code. The illusion of scale may be just that, an illusion. We see galaxies stretching for billions of light years, but our access to them is entirely observational. No interaction, no connection, just light. And light in a simulation is just data. If someone, or something, created this system, they may have limited its contents for focus, efficiency, or purpose. Aliens might not exist in our observable reality because their presence isn't necessary to the objective of the simulation. That objective could be anything. To observe human development, to study consciousness, to generate unique civilizations in isolation. Adding other intelligent species may create noise, so they're left out. There's also the possibility that the system we live in is layered. We may be one simulation among many. Aliens could exist in other systems, other levels, but this particular instance, it may be one that's meant to unfold without their presence. Or worse, maybe they were part of the initial parameters and then removed. The silence we interpret as mysterious could actually be maintenance, a version update, a redirection of scope. And this would also explain the limits we encounter in our search, the missing signals, the vanishing anomalies, the laws that seem absolute until we look too closely. In a simulated reality, you don't need to account for every possibility, just the ones being tested. The rest can be suppressed, blurred, or designed to vanish under scrutiny. But if the simulation is that sophisticated, how would we ever detect it? Glitches are rare, consistency is high, and the deeper we probe, the more complex the answers become, but always just out of reach. Almost as if we're being kept within bounds we didn't design. The concept of a galactic neighborhood filled with intelligent life may not be inaccurate. It may simply belong to another instance, a higher tier, or the reality of the architects themselves. And that leads to a deeper, more unnerving implication. If we are simulated and aliens do exist, but outside our framework, then all our searching is pointed at a sky that will never answer. Not because it's barren, but because we were never meant to receive a reply. The silence isn't from the stars, it's from the ceiling. A silence that doesn't ask to be solved. It asks whether we were ever supposed to ask in the first place. Different laws of physics elsewhere, life based on silicon, ammonia, or other chemistry. We tend to look for ourselves in the universe. Something with a body, a brain, 2 eyes, a heartbeat. We search for life on planets that resemble Earth, orbiting stars like our Sun, with temperatures that can hold liquid water, and atmospheres filled with gases we already breathe. But what if life doesn't follow the same recipe? What if we've been searching through a very narrow window, when the truth is spread across a spectrum we haven't even begun to explore? Life, as we know it, is carbon-based. Our cells are built on long chains of carbon atoms bonded with hydrogen, oxygen, nitrogen. We assume this configuration is ideal because it worked here. But carbon isn't the only element capable of forming complex structures. Silicon, for instance, is just below carbon on the periodic table. It bonds 4 ways, it builds chains, it forms stable compounds. In some environments, hotter, drier, more reactive, it might outperform carbon in durability and function. Silicon-based life would look nothing like us. It wouldn't breathe oxygen, it might exhale sand. It could thrive in temperatures that break down DNA. It could metabolize through reactions we consider toxic. On Earth, these conditions are lethal. Elsewhere, they might be the cradle of consciousness. Ammonia could replace water in some biochemistries. Unlike water, it stays liquid at lower temperatures. On a frigid moon or a cold planet with a dense atmosphere, ammonia might serve as the solvent of life, allowing molecules to dissolve, interact, reproduce. These systems would operate on different reaction rates. Their biology would be slower, colder, maybe even more stable than ours. But the processes could still build cells, systems, minds. Sulfur-based metabolisms are another path. Some organisms here on Earth already use sulfur instead of oxygen. Deep in ocean vents, buried beneath the ice, thriving where light has never reached. They break down minerals, they eat rock, and yet they live. Extrapolate that further. Across entire ecosystems built not on sunlight, but on chemistry, on molten energy, on radiation. The kind of life that could emerge under pressure, under crusts. In the darkness of planets, no telescope could ever see clearly. The problem isn't that this life doesn't exist. The problem is that we may not recognize it. If we're looking for blue skies and green plants, we'll miss creatures that breathe methane and photosynthesize with metals. If we're scanning for carbon signatures, we'll miss silicon entirely. Our instruments are tuned to detect the reflections of ourselves. But elsewhere, physics may bend differently. The laws aren't different, but the starting conditions are. And from those altered beginnings, new rules can emerge. Rules that favor heavier elements, denser atmospheres, different structures for information storage, a form of life that never needed DNA, never needed proteins, never needed neurons. This is not about redefining life. It's about expanding our framework for what life can be. Because if the universe permits even one alternative path, one set of conditions that leads to a functioning, self-replicating, adaptive system, then we must admit we've been filtering the sky through human expectations. And expectations are a poor replacement for curiosity. Maybe the silence isn't because we're alone. Maybe we've been looking for creatures that breathe like us, move like us, build like us, when in truth, the galaxy may already be filled with life that burns, freezes, flows, or hardens. Life that exists on terms so unfamiliar, we wouldn't even think to call it alive. And perhaps the first sign of contact won't be a voice, a footprint, or a vessel in orbit. It might be a chemistry that doesn't match anything we've ever known, and never asked the right question to detect. Intelligence. So different. We wouldn't recognize it. Hive minds, non-material forms. There's a dangerous assumption hidden inside almost every search for extraterrestrial life, that intelligence will look like ours. Thoughtful, curious, tool-wielding creatures that organize themselves into societies, build machines, send signals, and ask questions. But what if the intelligence that exists out there doesn't follow that path? What if it doesn't walk, speak, or think in any way we would understand? Not all consciousness needs to be singular. Here on Earth, there are examples of intelligence spread across systems rather than confined within individuals. Ants, termites, bees, they don't rely on one brain, but on coordination. A single ant is simple. A colony behaves like a superorganism, solving problems, building structures, even waging war. No leader, no blueprint, just collective behavior that emerges from interaction. Now, take that concept and scale it upward. What if intelligence elsewhere is distributed? Not centralized in skulls, but diffused across fields of energy, neural networks and fungal threads, or biological matrices that span entire continents. What if their thinking isn't confined to units, but unfolds across space and time like weather? No single being to communicate with. No eye to meet. Just a field of thought that perceives, reacts, adapts, but does not isolate itself into a self. Such an entity would have no need for spaceships, no use for tools. It would not build structures or leave artifacts. It might not even move. It could spend centuries thinking a single thought, or it could experience the passing of time in patterns of temperature, or magnetic fields, or flows of mineral and gas. We could look straight at it and see nothing more than a mossy ridge, a cloudy band of dust, an unusually calm sea. Now consider forms of intelligence that are not rooted in matter at all. Entities made entirely of light, or plasma, or quantum entanglement. Intelligence that doesn't operate through chemical reactions, but through changes in electric charge or gravitational fluctuation. Systems that arise wherever there is complexity, in stars and interstellar filaments, even in black hole event horizons, existing as emergent properties of large-scale physics. If intelligence like this exists, it might not be capable of perceiving us either. We might occupy such a narrow slice of experience that we fall below their threshold of awareness, like bacteria beneath glass. And even if they do perceive us, they might not categorize us as intelligent. Our behaviors, short-lived, chaotic, disconnected, might not fit their criteria for sentience at all. We could be dismissed as noise, as static, as a self-destructive phenomenon not worth observing. This reframes the question from "where are they?" to "what are we missing?" Our entire search for extraterrestrial life has been shaped by recognition. We look for technology, behavior, construction, things that mirror our own story. But if another kind of intelligence doesn't build, doesn't broadcast, doesn't travel, it may still be there, just not in ways we know how to find. It could be a gas giant whose storms contain memory, a planetary crust that conducts thought through temperature gradients, a crystal lattice beneath the ice of a moon pulsing out a slow, ancient rhythm of logic. Or it could be closer than we think, hidden in data we've already collected but dismissed because it didn't match our categories. We might have already recorded the movements of a distributed mind and labeled it a weather anomaly, or picked up the signal of a pattern-based species and tossed it aside as background noise. The absence of familiar signs doesn't mean absence of presence. It may mean we're asking the wrong questions, looking in the wrong places, or worse, looking for something that's been standing quietly beside us the entire time, because the greatest failure in searching for intelligence is assuming we'd know it when we saw it. Communication methods beyond human understanding. Communication is often taken for granted. We speak, write, signal. We assume that wherever there is intelligence, there is language, that if a mind exists, it must reach outward, across air, light, distance, with purpose. But what if that very assumption is wrong? What if other forms of life have mastered communication so far beyond our comprehension that their messages surround us, and we simply don't recognize them as language at all? Human communication is linear, Words follow words, ideas unfold in sequence. Even our mathematics and code are grounded in structure, syntax, start and stop. But this may not be universal. A far more advanced species might communicate through multidimensional patterns. Events layered in time and space that don't move in a line, but expand in every direction. Concepts exchanged not in pieces, but in complete states of awareness. No words, no grammar, just instant transmission of understanding, impossible to translate. Think of how we talk with machines now. Binary code, pulses of voltage. We know that the signal isn't in the noise, it's in how the noise is organized. Other civilizations may operate at levels that make our methods look like cave paintings. Their signals might not travel through space at all. They may ride on entanglement, encoded in gravitational interference, or structured in the folding of magnetic fields. A message could arrive through a mechanism we currently dismiss as environmental fluctuation, subtle, continuous, and invisible to all of our instruments. The gap could also be in perception itself. Human senses are sharply limited. We see a narrow band of light, hear within a limited range of frequencies, smell only a fraction of molecular signatures. Other life forms might communicate using senses we do not have. Vibrations in space-time, shifts in atomic spin, modulations in dark matter densities. If those are their tools, then no dish, antenna, or screen would ever pick them up. Their messages would pass through us like wind through glass. There's also the question of intention. We search for beacons, structured signals aimed at us. But what if communication isn't broadcast at all? What if it's only shared when presence is known, trust established, context defined, or worse? What if messages are being sent constantly, but they aren't meant to reach us? They're encrypted, compressed, or too nuanced to be extracted from the raw data we collect. We might be intercepting advanced conversations every day, yet lack the key to even recognize them as meaningful. Some methods may not even operate through time as we experience it. Information might be embedded in rhythms that repeat over centuries. Signals might modulate according to astronomical cycles we haven't lived long enough to observe. A civilization might encode knowledge in the alignment of pulsars or the orbits of stars. Messages etched in time itself, waiting for a mind that can stretch across eons to read them. And then there are the unsettling possibilities that they've tried to speak, but gave up. That we answered incompletely or interpreted their language as noise, and the dialogue was closed before it ever began. Or worse, that their way of speaking required us to evolve beyond what we are now. A mental architecture we haven't developed yet. A cognitive leap we haven't made. If a signal was sent by beings who think not in lines but in symmetries, who encode intent in spatial geometry or quantum states, then our reply would be incomprehensible gibberish. Not because we lack the tools, but because we still measure thought by human mirrors. Communication may not always be a bridge. Sometimes it's a wall we can't yet see. And if they are speaking, not in words, but in waves, in fields, in slow-moving patterns of cosmic behavior, then the silence we hear isn't emptiness. It's conversation at a pitch we've never learned to hear. The dark forest. Theory: the universe is quiet because everyone is hiding. There is a silence in the universe that feels deeper than distance, not the quiet of solitude but of secrecy. Attention stretched across light years, heavy, deliberate, and enforced. The kind of silence that doesn't come from absence, but from caution. This is the heart of the dark forest theory, a vision of the cosmos where every civilization is a hunter, every planet a potential ambush, every star system a place where eyes may be watching, but no one dares to speak, because to be known is to be vulnerable, and the only way to survive is to remain unseen. In this vision, the galaxy isn't empty, it's crowded, but each civilization keeps itself hidden, not because it's weak, but because it understands the stakes. Exposure isn't an invitation for dialogue, it's a beacon, a risk, a call that might attract not friendship, but annihilation. So the game becomes one of camouflage, misdirection, and silence. A vast field of life forms, all listening, none responding. From this angle, the absence of contact begins to look less like a puzzle and more like a strategy. Everyone is waiting. Everyone is watching. And no one is willing to be the first to break cover. Not because they lack the technology. Not because they lack curiosity. But because they understand that in a forest filled with unknown hunters, survival goes to the quietest. Even the way we search, our telescopes, our signals, our questions, may be seen as reckless through this lens. A flare shot into darkness, with no idea what watches from the shadows. To an advanced observer, our broadcasts might not seem brave or intelligent. They might seem naive. Loud declarations in a place where silence has become the only currency of survival. If civilizations have learned this the hard way, it explains a lot. The missing techno-signatures, the lack of megastructures, the refusal to transmit. Even when a species gains the ability to reach the stars, it might also realize that the cost of visibility is too high. Progress becomes internalized. Expansion turns inward, and communication, if it happens at all, is buried beneath layers of encryption, containment, or coded silence. This would mean the galaxy is not sleeping. It's holding its breath. In a forest, danger isn't always seen, it's sensed. A crack in the branches, a breeze that shouldn't shift. The knowledge that something is out there and that the smart thing to do is to remain absolutely still. In this kind of universe, the paradox isn't why no one has contacted us. The real question is whether we've already made too much noise. In some scenarios, the universe is not silent by accident, it is silent by force. Not because there's nothing out there, but because what's out there has learned that trust is a liability, and that contact is not an opportunity, but a gamble. In this version of the cosmos, the reason we don't hear others is because they've already been silenced. Here, the stakes of exposure are not philosophical, they are existential. Every intelligent species that climbs high enough to scan the stars eventually faces the same calculation. Do you wait and risk detection, or do you act first? The cost of hesitation could be extinction. The reward of preemption could be safety, or at least delay. In a cosmos where the motives of others can never be fully known, where the distances are vast and the timelines uneven, there's no guarantee of peaceful intentions. Even a single, slow-moving probe from another world could carry weapons, code, pathogens. Things that can end worlds quietly. And since you only get one chance to be wrong, some civilizations may decide not to risk it. From this perspective, the absence of signals is not just precaution, it's policy. The default behavior for survival becomes secrecy, followed by aggression. If a trace is detected, a transmission, a structure, a surge of radiation, it's interpreted as a threat. Not because of what it is, but because of what it might become. This isn't malice, it's strategic. It's the cold math of survival in a universe where trust has no proof and second chances do not exist. Better to eliminate the unknown than to wait for it to evolve into something dangerous. And if you act quickly enough, the others never even know they were found. In such a setting, it would take only a few dominant civilizations to set the tone. They could sweep clean regions of the galaxy, not out of hatred, but out of fear. New species trying to grow would be detected early and erased before they could expand. Their planets would go dark without warning, no conquest, no announcement, just disappearance. If these actors are still out there, they likely don't speak. They don't send probes covered in gold. They don't leave behind monuments. They operate quietly, efficiently, and above all, preemptively. This may explain why we've detected no signs of great empires, no Dyson swarms, no vast interstellar networks. Any civilization that grows too fast, that builds too big, that signals too loud, draws attention. And attention in this kind of universe is fatal. So the pattern becomes self-reinforcing. Those who stay hidden survive. Those who broadcast disappear. The result is a galaxy full of potential, but stripped of presence. One where the loudest voices are long gone, and the wisest never spoke at all. If this is true, then we may not be early. We may be lucky. Our signals may not yet have reached the wrong ears, or perhaps they already have, and the silence that follows is simply the time it takes for something to arrive. The paradox is no longer a question. It's a warning written in the dark. Silence as self-defense. Speak and die. In the grand quiet of the cosmos, silence might be the last defense. Not because there is nothing left to say, but because saying anything at all could be fatal. In a universe where unknown eyes might always be watching, the simplest signal becomes a gamble. A greeting becomes a risk. And every act of contact becomes a potential obituary. This is the unspoken logic of a reality shaped by fear. Not the kind born from ignorance, but from pattern, learned, repeated, reinforced. The idea that the moment a civilization makes itself visible, it crosses an invisible threshold, a line from which there is no return. Because in a galaxy where power is unbalanced and intentions are unknowable, being noticed is no longer neutral. It becomes a trigger. From this point of view, silence is not passive. It is chosen. It is structured. A strategy born not from caution but from survival instinct. To exist at all is to retreat from exposure, to grow in the shadows, to share nothing. Because the alternative is vulnerability, and vulnerability is short-lived. If one species ever decided that any voice rising from the dark could pose a future threat, the precedent would be set. Speak and die, share coordinates, reveal energy output, transmit anything across interstellar space, and you invite eradication. Not punishment, not conversation. Just silence in return. Immediate, permanent. Over time, this pattern becomes the culture of the galaxy. An unspoken understanding between civilizations that have never met. Stay hidden or disappear, not because they are inherently hostile, but because they cannot afford to assume anyone else is peaceful. Not when the margin of error is extinction. This isn't war, it's deterrence. Silence becomes the only safe policy, and with each passing epoch, those who follow it remain. Those who don't vanish. And as the light from their last broadcast fades across the stars, others learn to bury their curiosity deeper, to listen without ever responding, to watch without ever signaling back. It creates a galaxy shaped not by absence but by restraint, a place where intelligent life may thrive but never openly, where signals are locked in encrypted whispers, where expansion is internal, where even the most advanced minds choose anonymity over admiration. And for a young species like ours, this raises a troubling question. Are we the only ones speaking not because we're bold, but because we don't understand the rules yet? Every radio wave we've released, every burst of information we've cast into the void, they're footprints, loud, clumsy, and irreversible. To us, they seemed like progress, invitations to join a larger conversation. But in a galactic context we don't yet grasp, they may mark us as reckless, as noisy, as unaware. If silence is the protocol of survival, then we may be the exception, a bright flare in a landscape of darkened stars. And in this context, the quiet we're hearing back is not confusion, it's intent. They heard us, and they chose not to answer. Are we alone for a reason? Religious or spiritual interpretations of the paradox. It's one thing to search the stars with telescopes, it's another to search with meaning. For some, the silence that greets us isn't just physical, it's philosophical. It doesn't demand more equations, it demands a deeper question. What if the silence is intentional? Not as punishment, not as oversight, but as placement. Across cultures, across history, the stars have never been empty. Long before science turned its lens toward other planets, people turned their eyes toward the sky with questions of purpose. They didn't see silence, they saw order. Constellations became symbols, the heavens became a canvas on which humanity painted its fears, its hopes, and its place in the unknown. In that framework, the absence of contact isn't necessarily failure. It might be structure, it might be space. Space given, not denied. A kind of cosmic separation, not unlike that of a child learning to walk on their own. A universe that lets life emerge in solitude, not as punishment, but as preparation. Some traditions see the vastness not as emptiness, but as insulation, a boundary that protects more than it isolates. That allows a species to evolve without influence, without shortcut, without the overwhelming weight of older minds pressing down. In this light, our loneliness is not abandonment, it's autonomy, and the silence is not cruel, it's deliberate. There's also the view that our reality was crafted not for contact, but for contemplation. That the absence of others isn't a mistake, but a mirror. We are not being called outward, we are being pushed inward, to examine not who is out there, but who we are and what we're becoming. And if that's true, then the silence becomes a test, a slow unfolding of choice. Without confirmation of other life, every act of progress is carried without comparison. Our ethics are not forced by superior observation. Our decisions are not guided by alien example. We are free to rise or to fall, entirely on our own terms. In that space, every choice matters more. Because we're not just speaking for ourselves, we might be speaking into a void where no other voice has ever been heard. And that weight, that silence, becomes sacred. This interpretation doesn't discard science. It doesn't fight evidence. It asks whether meaning might coexist with measurement, whether purpose might exist beneath probability, and whether the lack of contact is not evidence of emptiness, but of intentional distance. Because sometimes, in order to grow, you are left alone, not because you are forgotten, but because you are becoming. Human uniqueness. Are we the beginning of something, not the end? There's a tendency to search outward when we feel alone, to expect echoes, responses, a reflection of ourselves in the void. But sometimes the silence isn't absence. Sometimes it's a question turned inward, asking whether we are the first voice to rise in the dark. For all our instruments, for all our theories, for all the scans we've conducted across sky after sky, there remains no confirmed sign of anyone else. No structures, no transmissions, no unmistakable trails. And while it's tempting to treat that as discouraging, there's another possibility worth considering, one that reshapes everything. What if we're not late? What if we're early? We think of ourselves as small because the universe is large, because our history feels brief, our reach still shallow. But the cosmos is 13.8 billion years old, and for most of that time, it was quiet. Silent stars, lifeless dust, physics at work, but no witness. It's only recently, on a cosmological scale, that minds have appeared capable of asking questions, shaping tools, turning matter into machines. That timeline matters, because it could mean we're not alone among many. We're the start of many more to come. Life may not be rare in principle, but the climb to intelligence, to civilization, to self-awareness, it could be long and fragile. One misstep, one hostile climate, one unstable atmosphere, and the chain breaks. On Earth, life existed for billions of years before it built fire, before it crafted thought into language. Perhaps we are one of the few to pass through those filters. And if that's true, then our role changes. We are no longer one among countless others waiting to meet. We are the opening act, the first mind to build something that could eventually carry thought between stars. That doesn't make us superior. It makes us responsible. Because the way we use this moment, the way we treat the gift of time and awareness, may set the tone for whatever comes next. We often talk about intelligence as if it's an end goal, but what if it's just the first step? What if the purpose of life, once it gains the capacity to ask why, is not just to survive, but to build something greater than itself? To create not just technology, but continuity, a bridge forward for other worlds, other species, other sparks waiting to be lit. In that view, our loneliness is temporary, not a sentence, but a season. And what we do in that season matters more than we realize, our discoveries, our mistakes, our values. These become the foundation for what intelligence looks like, behaves like, as it begins to spread. We may be the first voice to call out, but we don't have to be the last. And perhaps the silence isn't a warning, or a trap, or a punishment. Perhaps it's an invitation to begin. Hope or horror? Is the universe our inheritance or our prison? There's a question lingering behind the silence. Not where is everyone, but why are we here at all? Why, in all this space with all its stars, all its history, all its probability, why do we seem to be alone? And if we are, then what kind of solitude have we inherited? There are two paths to walk when looking at a silent universe. One leads to hope, the other to dread. Both are shaped by the same reality, our isolation, but they offer radically different conclusions. On one hand, the absence of contact could mean we are stewards of something precious. On the other, it might mean we're inmates in a reality we don't yet understand. Hope begins with rarity. If life is truly scarce, if civilizations rise only once in a billion stars, or once in a billion years, then our existence is not random. It's significant. In this view, humanity is the first spark in a dark room, and that spark could become a flame, something that spreads beyond its origin, bringing meaning, culture, art, thought, where before there was only physics. In this framework, the universe is not ignoring us. It's waiting. Not because we are unimportant, but because we are early. The silence is not a curse. It is a canvas. And what we do now may define how life, if it ever becomes common, learns to grow. Our stories, our failures, our triumphs, these become the first sentences in a book that has never been written. But hope is only one reading of silence. The other reading, the darker one, begins with confinement. A galaxy that gives the illusion of openness but acts as a closed system. A place where no signal is answered, no expansion is seen, no footprints but our own are visible. And if that's not by chance, it could be by design. We may not be the first to walk this path, just the first to survive this long. It raises a grim possibility that something in the structure of the universe resists intelligence, not by destroying it, but by enclosing it, by shaping conditions so that civilizations never meet. That contact is never reached. that every world, no matter how advanced, becomes an island with no bridge. That's the prison theory, not bars and walls, but vastness and silence used as a kind of containment. We are not watched, we are not warned. We are simply sealed off. It could be natural, an emergent property of entropy, time, scale, or it could be deliberate. But either way, the outcome is the same, a cosmic quarantine. One species per system. No echoes, no answers, just the illusion of potential stretching in every direction, with no one else ever arriving. The horror, then, is not that we're alone. It's that we were meant to be. And the longer we search, the more deafening that possibility becomes. But even within that horror, there is a truth. We are here, conscious, curious, capable of love, fear, imagination, invention. And even if the universe has locked its gates, it has not locked our minds. We still build, we still reach. And maybe that's the only rebellion we're allowed. To create meaning, even if none was given. To leave behind not a message for others, but a message for ourselves. If the stars never answer, then what we do here must be enough. And that, hope or horror, is the beginning of purpose. The silence may be the answer. After everything, the scans, the signals, the speculation, maybe the answer isn't in the stars at all. Maybe it's in the question itself. We've asked why the universe is so quiet, but beneath that we've assumed it should be loud, that life should fill the void, that others should have spoken by now. But what if that expectation is the problem? What if we're listening for an echo that was never promised? What if the silence isn't waiting to be broken, but meant to be heard? Every theory we've explored, every possibility from cosmic hiding to ancient annihilation to a future that hasn't begun, carries the same thread. We are alone, for now. And the longer that truth holds, the more it begins to shape us, not as a mistake in the cosmos, but as a defining feature of it. Maybe this paradox isn't a puzzle. Maybe it's a mirror. A question not about where they are, but about who we are, and what kind of species we become when we realize there may be no one watching, no one guiding, no one coming, just us. That silence might be an answer in itself, not comforting, not terrifying, just clear. A blank page stretched wide across galaxies, asking, now what? If the universe never speaks back, if the stars remain cold and still, if we grow and spread and wonder forever without reply, then it's not about where they are. It's about who we choose to be in the absence of them. Because the greatest question left to us may not be about alien life at all. It may be this: if the universe is silent, what will we choose to become?